जन गण मन अधिनायक जय हे। भारत संविधान भारत भाग्य विधाता। पूर्व पश्चिम उत्तर दक्षिण उत्तर पूर्व उत्तर पश्चिम दक्षिण पूर्व दक्षिण पश्चिम। विंध्य हिमाचल तावी यमुना सरस्वती कृष्णा ब्रह्मपुत्र गंगा उछल जलती तिरंगा। तब शुभ नामे जागे तब शुभ आशीष मांगे गाहे तब जय गाथा। भारत सर्वधर्म नागरिक भारत विधाता। जन गण मन अधिनायक जय हे। भारत संविधान भारत भाग्य विधाता। जय हे जय हे जय हे जय 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 हे। जय भारत वंदे मातरम। सुजलम सुफलम मलया शीतलम सासिया श्यामलम मातरम वंदे मातरम। जय भारत। Sorry, gentlemen, yesterday there was some problem with Facebook. I could not talk to you at length. Let us see today what happens. Management talk is very crucial from everybody point of view. Everybody is concerned with it. Whether you are working or you are not working, you have to learn it. You are a student, you are a practical person, you are a citizen in engineering, or you are a citizen somewhere else, all over the world. It's not only constrained to our country. It's very significant issue because somewhere you have to manage. And I'm not talking of general management and not business administration management. I'm talking of work management. I am related to, by my profession, construction and design of civil engineering works. It's my specialty. But this specialty relates to everybody because here involvement is for technical work, involvement is for codes, involvement to design procedures and designs, and interrelations with other professionals like electrical, mechanical, architectural, and all those, or computer, CCTV, SCADA, and all, which at one time or some other time come into picture on project management. That point must be kept in our consideration because we cannot move in isolation. Project management is something which can be defined in many ways. Your definition, my definition can differ, but ultimately, production of goods, production of requirement, that's main point. You may be mechanical engineer or electrical engineer, your destination is different. But at one point of time, you have to come to that structure, deal with that. Coordination, correlation, many other liaison work, study work, drawing study, specific study, all are to be interlinked. This is where we stand. Even if in market you go to buy something, that person is not in isolation because that person, that hawker or vendor deals with some other and that person deals with someone else. So there's a chain of supply, there's a chain of work, there's a chain of delivery. Same we are. We have to deal with every corner, every point in that process with everybody. And that is where we stand for this. This means we cannot jump away that this I have done and I am responsible for this. This is a technique that every person has to come in, particularly in modern world when we cannot simply isolate ourselves. So project management means involves quality, quantity, time, cost, relations of communication, you may say public relation, internal relation, and management of resources, management of risks. All these factors fall into this category you all know. Maybe 8 factors, 9 factors, various factors are there. You can add whatever factor you want to that impacts upon your project. But prime factor is cost or budget that we need. And if we don't have budget, we cannot start even, we cannot think even about whatever project, green project or brown project. We need something. That point we have to understand that prime consideration is money, that is power. If that is not there, you cannot even think of anything. Then comes after that time. Your money and your time both are related. If your time is not valued, your money cost shall escalate. X shall go to x plus 1, x plus 2. If x is your original money, this means escalation can impact your project. Escalation of time, escalation of cost, escalation of whatever, and then come quality. Quality, very important factor, which values your time and values your budget. If you cannot maintain quality, your money has gone waste and your time has gone waste because you forgot quality, which cannot be seen and it cannot be measured in quantity, which can be measured only in its standard. This standard project is substandard project, or it is rejected project, or it is valued project. There can be categories like this. If it is a valued project, means added value is there, very good, means you get some additional return for that, and customer is super satisfied, though it is we call satisfied, but if I get return more than expectation, certainly I will be happy, and that is only a criteria to be considered, where we say customer satisfaction is final destination. But I don't agree with this 100%. Well, it's not customer satisfaction, it is goods requirement satisfaction, that supplied good or supplied whatever it is must perform. So it's not exclusively customer satisfaction, because customer satisfaction cannot be achieved in one day. There, it takes time. Means this product has to establish that this is a reliable product. It should work for many years or for that duration which was designed for it. It may be designed for 5 years or 10 years or 100 years, and you cannot say that you can get satisfaction in one day. You cannot get. Yes, you can say I would. This is a just like they say, I have received this product which is without defects. Yes, it's up to defects it is satisfied. They never say that you have received this project, sorry, this material, or this good which contains all properties, all criteria, and you are satisfied with that. I cannot say that is statement right. Yes, defects free it is. It's one working condition. Only that condition they can demand and we can sign. But is that satisfaction criteria? That we have to think. You are experienced person. You cannot say that this product shall work for so long duration. You cannot guarantee that, but it is assumed only. So this is assumed satisfaction. It is not real satisfaction. Customer is satisfied provided there are certain conditions which will be met in future. Probably, who knows? If this yes, and they give guarantee also. This is warranty or this is guarantee. That's only a sales tactics. You see, they will give guarantee for its lifetime sometimes, and then the lifetime. Oh, 3 years was it lifetime? They can say, but they won't define that. Means it is not whole life. You are thinking that is for your whole life, but they have different definition of life. It happens. This is business. Every business cheats you and you are cheated. Well, this is business, and people do that. This beyond your control. You forget after buying something, and even if it's out of service, it's not working order, you don't care for the, okay, who bothers about it, why should I run behind that? This happens. Everybody is not serious, and who has time for all this? There's no time for that. But if you have time, you can be serious. That's where I say we have to be serious in management, not by, you may say, managing only, but thinking how to manage. As when you think how to manage, means books, keep books off, means these are not required. Business administration books and all other books are only, theoretical, where they don't have experience, but they write books. Those books and those degrees of MBAs and others, they are not relevant to real world. Yes, they are fancy degrees, very fancy. I accept that. They give you job also, fine, you get job through them. But is your job only destination? That's the point. If you think your degree means only to get a job, then you are a limited person, not unlimited person. Your destination is very narrow. You cannot Gain risk, you cannot, I say gain risk because risk is also sometimes helpful and right. If you do not take risk, if you do not accept risk, you cannot move further. Yes, risk will drop you sometimes. Risk will give you danger. Yes, you are in danger because of risk. But if you understand that as a pre-hand, all in hand with your hand, you have pre-solution. That's what's required. That's what's management. Management teaches think before something happens. That's what your education is all about. If you just cram something, pass exams, I am educated one. No, they are not educated one. You are educated by books. You are not educated by experience. Book is only for 2 years, 3 years, 4 years, 5 years maximum. After that, you are your own book. You have to use your knowledge. You have to use your quality, your quantity inside you. Then you can understand what is management. To give something in compliance with complete requirements in time with proper support, that can to some extent be defined as, it defines itself, management. So these 3 points, as I told you before also, every time I say cost, quality and time, these triangular corner factors and supported by many other factors are very important to be understood. Quantity production with speed is acceptable, is recognized, provided it is backed up by quantity and quality. Simply saying I'm delivering this and out of 10 products delivered, 7 products are defective. So can you call that quality product? Okay, forget time, for instance, just we ignore time also. You can take more time, you can give us better product. But if still you don't go better, you have lost time and you have lost quality. Only there is a product which may be useful or which may not be useful. This we have to control. This control is very important, and if someone controls that, that person is reliable, that person can think, that person can work hard, that person can concentrate, and that is where we need our attitude to be. I am involved about buildings, involved about some other structures. Those are very expensive activities. It may be small one, but it's very expensive. It may be a small one or very big one. On very big projects, you get supports from everywhere, from all people. They want to sell their material, they want to do work for you, service for you. You will not find great difficulty when you have a big project, considerable size project. But when you have your own house, for example, your very small work, people shall not come to you. You have to struggle yourself because market demands quantity and quantity demands money. So they are interested where their material is sold in bulk. This is market. But here problem is, if you go to buy something and ask for certain technical backup of that, nobody shall provide you. Even if you go to buy cement, for example, you may buy any trade cement and you ask that vendor, can you provide me properties of this cement or data sheet of that cement? You will not get that. And if you ask this factory who's producing that cement, they shall give you certain data which is not very clear. They will just write such fake properties and they say that's all we can give you. This means there is a bar in business itself, in trade itself. You cannot get your satisfactory answer. That's where you lack. You buy steel, you buy some other material, and you demand properties, working properties of that, or mill scale. You will not get mill scale. I mean to say, when you buy steel reinforcement, there's a mill testing on that. You will not get here anything. Even if this there, oh, this is just manipulated one. And certainly you are not going to test it because you will not find any reliable laboratory, material testing laboratory for that. So how can you get satisfaction? Means you will depend upon that information that vendor provides you or that manufacturing unit provides you. So you are not sure what this product, this can be recycled still, how do you know? This can be not complied still, how do you know? They would say this steel is excellent one and we are best one. All they would say, same way cement supplier would say, we are best one, we cheapest one. This is common advertisement. But we don't believe it. I don't believe that. I want to ensure I'm going to spend millions of rupees, crores of rupees on this project. I want to show that this is that product which I require. And I don't believe in codes also, because codes are also very obsolete. All codes were drawn many years back and decades back, and we cannot rely upon them. Technology keeps on changing every day, every hour, every year, every month. Changes and changes and changes do occur, but at least whatever we have got information on papers, on codes, that we complied with at least. But no, that's not. You are confused, they are confused, everybody is confused. But we are living, we are working. Well, leave it aside. We just depend on that. Even after depending on that, are we happy that what we get, what we construct is okay? That construction cannot be confirmed by anyone. Builder, promoter, engineer, employer, workers, whosoever. They say, yes, we have achieved our target, but that is not quality target. Time target, that is. Quantity target, that is. Quality and workmanship are unclear. You have no quality, internal quality, external quality, properties quality, data quality, and workmanship, because your workers are not well trained. Just tell me, where are institutions which train these workers, construction workers, mechanical workers, electrical workers? You may say there are ITIs and some other institutions. Yes, there are, but you think they are adequate one? Who can train your workers? Your these working staff like these tradespeople, artisans, and other workers. Either foreman can train them, or engineer can train them, or they get training from their own parent if they are really that type of skilled people. And this means we must understand a skill development program runs all over the world. We are also running that program, but have you got some information to what extent that has been successful? You won't have any information, because they don't understand what is successful means here. Skill development means what? A skill may applies to everybody. It applies to me, but to you as well. You are an engineer, you are a manager, or you are an administrator, or whatever you are. Skill applies to you also. To an extent, it applies to lowest category of worker. It applies to everybody. So, did you ever think, measure what difference of skill did you get when you passed your engineering degree or your other professional degree, and now what you are? Did you ever measure that? If you have measured, I think you can understand that. And if you have not measured, you have to measure it now. Do you find any difference between that attainment you had when you passed your qualification, and now after a gap of 5 years, 10 years, 15 years, 20 years? What difference you are noticing? Do you stick to your text knowledge, or you stick to your practical knowledge? And what you learned in your practical knowledge, does it equal to that you learned in university? No, you will not find that. You cannot measure that. Sometimes what you are working is useless. Yes, you are working, you are on job, you are delivering that job also, but question again comes in. People accept that job, everybody accepts the job, but that job is not perfect job. That's not perfect item, perfect delivery, because we are not sure about what we are doing. If you go to government, they say, okay, we accept CPWD specifications, or we accept these specifications, and there's a volume of that. There's a volume of specifications, there's a volume of analysis of rates, and there's a volume of items in schedule of rates. Everything is available. But question comes in, is that right? When it was produced, this was delivered maybe 20 years back, 15 years back, and when it was delivered 15 years back, how many years were taken to compose that book? So it's about 30 years back, you can say. That material, that sort of information you have in government or in those areas where you're working is very obsolete, and you are using obsolete information in a profession because you are not updated one. For example, concrete pumps, concrete forcing pump, stationary pumps which people are using. I have not seen mobile pumps here. Maybe they are available somewhere, maybe in Bombay or somewhere else. I don't know, I'm not sure of this. But this stationary pumps for concreting we are using here on every project. Some mixer, transit mixer delivers concrete, and there's a stationary pump. Stationary pump, I mean to say, is installed at one position. There is a pipe that en route goes there and goes up to that location of concrete, and every time they change this route. That's called a stationary pump, which was used in 1980. It was used in 1980, not now. But we still depend upon that. In 1980, 40 years back, that pump was used. This means now it is obsolete, but we use it. That is our beauty of attraction. We do like this. Mobile pump, also it was used in those days. It's a powerful pump, but we don't, I have not seen it. Similarly, these transit mixers, other technology that we are using, we have to understand that in professional work, we have to match with other countries, other world. We as workers, we are okay. As worker, as engineer, whatever we are, when we go to overseas countries, there we develop ourselves, our skills. We are forced to develop, not because we like to develop. If we do not develop, we cannot continue. That is our compulsion. That compulsion does not exist here. That is the difference only. I was in government for 6 years in the beginning of my career in Delhi, but I could not learn anything there except what you call it, that term I can't say, except time pass or just be busy in valuations or in making bills of payments for contracting job, just entering measurements. And like that job means I did not know what actually engineering was because there is no engineering. There's a definition you have to limit to yourself. There's nothing else. You cannot take risk. You cannot fight people. If you fight with contractors, if you fight with others, they fight with you. This is our philosophy. If suppose I am in government, I am an honest person, I want to dedicate and devote my services to my nation, I want to ensure quality must be achieved. If you decide that, means you decide something against you. You have no right to demand quality. You have no right to demand efficiency. You have only right to accept what they do. If you struggle, you fight with system, you will be thrown out of system. That is first principles in our management in this country. Do not struggle, do not be arrogant, do not stick to rules, to specifications. Just let what goes on as it is. This is our prime definition of quality. Move with system or get out system. Either move or get out. Only two options, no third options. So you have to decide yourself. You may say, I have been in this service for 25 or 30 years. As long as you are in service, you are efficient person, though you do not know anything. That's first principle in our government sector as well as in private sector. It's no difference. Private sector is also equal to government sector because they also want to make money. They don't want to struggle with government rules and government people. They have to manage. So system is a little different. This is not criticism of system. This is fact that I have observed and still observing. This is status of professionals. I am not talking about non-professionals like administration officers, IASs and others. I don't consider them having any contributory factor towards development of this nation because they are just busy in wasting time of others. They are happiest people if they stop work. That is their skill. So here I am not finding any criteria where does skill exist. If you find that, it's fine. You can also send a message to me that you have this answer, and I am sure if I get that, I will use that in my work, and I will tell others that this is skill degree which we have, but we don't have. And if you are not skilled as engineers or as managers, I'm not talking of professors. Their skill can never be there. They are student teaching only. So they can't have any specific skill in practice. They may be called expert by some courts or someone else. Because courts themselves are not experts, they can call them experts. No problem to that. But you are not independent. Remember, You are running, you always run a team of people who are neither very well educated nor very you can say they know job, but they know job only quantity terms. Their skill requires to be refined. And this is your job, foreman's job, supervisor's job. This part of job we have to take into our actions, incorporate that. That's where we are missing. But first we have to learn that. Sometimes what happens, we experience some job, observe that for decades, and we think that is only right, that's only correct. Because our mindset receives that all time. Yes, that's right. If you want to that worker, your job is not according to them. No, sir, I have done it for 20, 30 years. How do you say that? This is best what I do, and I guarantee you about this. This statement you always receive from these people. And this is not due to their fault. This is due to their confidence and overconfidence. And we accept that. Knowingly that this is not right work, this is not markable work. But we accept that. There's no other way. So skill development in our profession is very wide. Because we have to understand skill first, and that's part of management. Now we say professional development, very wide term, very modern term it is. You have to develop professionally. This means when you studied, you did not develop, you did not learn professionally, you were textually or academically. You have to apply that, and based on that application, whatever sequences and results you get, that's a program you learn in field. And if you get that opportunity only, if you get that opportunity and you do not learn, you waste your time. Yes, you are getting salary, you get whatever work done, nobody will object to that, and you deliver and come back. But when work fails, you have no response to that. Why did it fail? Why did it not work? When you do concrete on pavements and after few weeks or few days you find settlement of that concrete or some cracking there, you have no reliable answer, satisfactory answer to that, and you even don't care for that. And nobody is going to ask you also, because nobody notices that. But at some time it becomes useless, though traffic moves on that, because nobody cares. And after some weeks or few months, another person comes, another contractor comes and excavates that pavement and lays his pipeline or cable or some other thing. So your defects are excavated, exact, your cracks are excavated. So you say there is no problem there. That is what I say. What I understand, according to my mind, we should not do this. We have to think about how to improve that. And you are not going to add money onto that. You are not going to add expenditure onto that, because that is part of activity. Only the problem is that ignorance exists. I am ignorant, you are ignorant. We sometimes condone something, we accept something we should not accept. That is only a problem. When some during Congress somebody forgets to apply vibrator at right time, and we do not notice and we do not force that person, and it becomes a defect. It leads to hollow or void in concrete, or honeycombing, or sometimes they over apply that. That's also a defect. Segregation is same. All these points are very minor but very significant. If concrete becomes porous, do you think there is a solution? In column, in beam, or anywhere, you deliver some porous concrete in some part, then do you have any solution of that? Even if you have solution for that, it is time consuming, cost consuming, and quality criteria required there. Means you have to work additionally on that. Had you worked at a time of application or pouring, you would not have found that difficulty there. That's what I want to say. Constant supervision. I'm not saying by you, by your staff, by your technical staff, supervisory crew. Those people must be explained before work is started, what parameters they have to check. That is where quality lies. That is where improvement lies. Those parameters you have to decide. Not administrator, not someone else, and not a person who devised designs for you, because that person himself does not know those criteria, though drawings are produced by that person. That person does not write that thing in details on drawings, but ultimately it's your job to produce quality and quantity based on those drawings. So it is your duty, and that duty how you have to do, you have to think. I am sometimes very, upset seeing all these works done in cities or wherever without any, you can say, what I should say, without any factor, without any incorporation of quality criteria. They just do it. They just do it like a layman, lay worker, without understanding aftermaths of that. Nobody bothers. Even lines are not seen in state, workmanship, survey work is not done correctly. Nobody is sure about verticality of walls or vertical members. They do it. Means they spend money, they do shuttering, everything, but but skill of workmanship, skill of quality is absent. So what you can speak about that, that you have to understand, I have to understand. I am not saying that I am perfect, but at least you are thinking. And if you think one time, two times, three times, certainly it shall be a part of your mind. It shall force you sometime to take a few minutes from your schedule and go check this. That is what is required. You chat too much with people. You go to some creative parties. That time you have. You cannot read time, or you cannot go to your books or read something, or you write yourself and create some book. Maybe you are excellent one. You are very good engineer, I may say, I may expect. You are excellent engineer. You are excellent foreman. You know job, but that is inside you. You have to extract it, eject from your mouth and mind, and either explain to them or write it. And if you write it, it becomes permanent. It becomes a source or a resource for reference. That misses. That documentation misses. If you make a scheme that I shall not allow any activity without either it is given in writing by myself, or I get it done by some other person who has experience in that, and then everybody has to follow it, I think it shall be best policy. You write something yourself based on your knowledge and experience, and you think that it is perfect, it is compliant to requirement, and then you deliver to others for implementation with their explanation, to be clear that they understand. It doesn't matter if you have to explain them many times. Explaining many times is far better than allowing wastage of work, wastage of material. You may explain one time if that person is intelligent enough, or you may have to explain two times, three times, or let somebody else explain to that person. Only destiny is, only target or objective is that that person must understand what is to be done, and then you have to supervise or surveillance on that person. If that person is suitable, that person is competent to follow that, that person shall become expert on that activity in a couple of weeks, and you can consider that person as your resource for that activity. And so many persons are there with that level. You can consider as expert crew. So what happens, we produce concrete crew, we produce formwork crew, masonry crew, and like that you produce surveying crew. You can yourself deliver clues to your project, and they are called expert groups. And that is a called part of training or job training. This is job training. This is nothing new I am explaining. You were also given some training by someone and you got job experience. And that training is very important in field. We cannot take it for granted. No, this is not. You have to. So my statement is just meant for that it is you who has to become your teacher. Self study, self discovery. What is to be done? You cannot depend upon texts written by others because others have written what they think about. You have to write what you think about. This is habit of writing, means what you think. You are standing on site, for example. You are busy on activities. You are not busy in watching who is going and who is coming on road. You are watching your work, you are supervising that, and you observe many points which must be corrected, and you do that corrected. But that must be written. I call, and not only I, this is a procedure that whatever you do, you must have that statement in writing. And that is termed as method statement or procedure. This method statement is used as a document, as a support for those activities, and you can create many method statements for general activities and specific method statements for specific activities. Technical methods these are, work method these are. You shall not find them in your specifications or your books. Specifications are technical ones. These are different. Those specifications demand something, and that is very complicated one also and too easy. Those you can comply with, and based on information you receive from such specifications, you have to chart out your procedure. This procedure is technical writing. This procedure is administrative writing, as well as material inclusion, safety criteria, quality criteria. All this, all these points, all these sub disciplines must be covered briefly in your method in statement. If you can understand that, it may be only 2 or 3 page, 4 page sometimes, and it's very big one, maybe 10 pages of writing. It takes time, but once you write something, you can produce that method statements or some other activity just by editing your original copy. But once you make it as a policy, you can give that method statement what you wrote to someone else to follow, and that person must follow that. This is procedure to make work easy. Because what you learned, you are writing that. What you experienced for successful result, satisfactory result, you are writing that. It's a kind of, you can say, observational research or operational research. You are finding many techniques there itself, which you did not, which was because academically you learned that, but you could not understand that. Now practically we have to learn it. And not only we have to learn it, but also we have to teach our juniors. Your junior, his junior, and junior further, and all workers. This you have to ensure if you want to achieve some quality criteria on your activities. Just like we do not do, but it is required. Temperature, for example. Temperature, what is atmospheric temperature when you are working? Because if no temperature, you feel it, but you are not taking care of that. Because temperature not only affects your activities quality, it affects your worker's skill. It's too hot, you can't expect worker to deliver you 100% efficiency. Never possible. In that case, you have to understand that you have to help worker also. You cannot simply say you're a machine and you do it. Workers can also be impacted upon sunstroke, heat stroke. That safety criteria you have to include in your method. And then solution of that. Can they can you do that? You will not even think of that. Worker is a resource. You have to take care of the resource. When your machine breaks, you care it or no? You repair it or no? You call some technician or no? When your machine stops, do you add diesel or petrol to that or no? You do that. Same way, you have your friend, your junior worker, who depends upon your support to remain efficient. So you are required to care about that, and that is what human resources relation and human resources reliability come into play. You expect work, these people should do for you, but you don't help them. Who shall help them? That skill is very important factor. That's very important factor here. Let me just who is a That's very important factor here. We have to understand. And if you don't understand the factor, we lose something. And that something is very important for everybody to know. Who's there? Anybody, please? I'm not getting an answer. Hello? 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 You're not speaking? Why you call? Necessary. Sorry. So what I say, if you are missing something, you have to chart it back. Bring back because you are professional. Identification of some missing item is not a problem for you, but you require concentration. You require concentration for your each activity. You cannot take that for granted. Oh, no problem. My mason shall take care of you. My supervisor will take care of you. Yes, your supervisor, your foreman, your skilled leader, charge hand would take care of that. But if that person knows about that, if that person is warned about that, you may say you will take care of that. Now, example I give you, excavation. You are excavating, you have dressed your level, and you think this person shall take care of compaction of formation. Because you told him, you instructed him. But are you sure that person is taken care of? Because you did not provide any support to that person. You excavated. This means you use your machine to excavate that. Machine has disturbed that formation. Certainly it would. That undisturbed soil, which had been there for years, may be properly consolidated. By excavation, we disturb that natural property. And you think just level it with that and sprinkle some water shall reinstate that property. In that case, you are wrong. And that person, that worker does not understand this. It's okay, we have to put some water and okay, let's level it and start work on that. Or use some manual rammer, this I think 5 kilogram rammer or something. You think that can compact it? That is where you are looking. You procure, you get some compactor or plate vibrator and you have to do that. If it's suitable ground for that, you may say, no, this is different soil. If it is different soil, then you have to improve that soil. It's not written in your specification, it's not written in your drawing, but you are engineer. I cannot blame architect because architect doesn't know about that. He is not taught about that. Maybe he's taught, he did not care about that. He didn't go to site and investigate soil or excavate a pit and see how soil was. They are royal, they don't go. They depend upon others' information. But you are not royal, you are only engineer. He is a big man, he is an architect, forget that man. But you are real engineer. You are responsible for that work. And if you do not take care of that, okay, do it. Is that right? Formation level of whatever structure is very important. If it is not good, it's not reliable, your everything is rubbish. Everything is rubbish. Because your base is not strong. You did not make sure that it is having strength, and you worked on that. On whose reliability? On whose guarantee? On soil's guarantee. Soil is weak there. It disturbs soil. You do not have check bearing capacity of that. You do not take a sample to laboratory and you start it work. And if you take to laboratory, somebody manipulates that and gets correct report. Did you take field density? You did not take. You should have taken. If you have taken FDD, field dry density, at least you would have known to what extent it has been compacted to 98% or 95% or 102%. You don't know that. You did not bring machine and compact that. And maybe there's rain on that after that, before your work. So again it is disturbed. It is probably clay soil or silty soil. You have to see, but nobody cares. At least, oh, this is very small work. This is a drain. This is a compound wall. This is that. Even if it is a building, you will not care for that. That is where I say problem is. Means starting is wrong. Forget other items. If starting is wrong, whatever you want to, structure is very strong, foundation is very strong, column is very strong. Receiver at end is weak. And if you think soil is not good, is not sustainable for foundation, it may sink or it may subside, then what you have to do? Maybe work is small. That is where we have to work. That is where engineer is required to think, to see, to ensure something. And if we do not do that, then I think my justification is not there. I should not be there. You should not be there. What for we are here? For name's sake? If we have to depend upon my person, my worker who is not a skilled one, if I have to depend upon a contractor who has no interest in quality, then who is father of quality, who is guardian of quality, who is director of quality, there is no one as such. So quality has been, ignored. You can say it is been no care for that. You have taken no care for that. So it is your fault. I would not blame contractor. I would not blame worker, because they are your students. You have to teach them. Or if maybe contractor, say engineer, I can say that person is responsible if you are not responsible. That person is automatically responsible because that person is equally qualified to yourself. If you are only qualified, that person is also qualified. That person cannot run away. But it's better so to say. So why I am explaining all this? We fail everywhere in quality, and when we fail in quality, we fail in skills development, and we fail in designs development. A skill comes from everywhere. Because when you are working on site or wherever you are working, you are depending on some designs delivered by others. And these designs you try to know every time on every project. You are exposed to new designs, and you must understand that to some extent why this design is as such. Or you can ask that designer what criteria, what factors have been considered, and why this has been. So that's called a kind of practical review. Even though it is proof checked or something, when a site person works and he reviews that drawing, that person reviews from viewpoint of prosecution or activity or execution. From that point of view, site guy, or you may say layman, understands. Layman has problems of execution, problem of construction, various problems like easy construction one should do, or one should have a drawing that leads not to to a state where you can comfortably work, your workers can comfortably work. There's no fabrication problem, there's no such problem of size of element or size of column or size of beam. It should be in a way that easy way it should, and you have to explain this to your designer. Don't complicate too much. Don't congest reinforcement, for example. Don't adopt sizes of these beams and columns too narrow. They should be comfortable, accommodate steel and vibrator application. This you have to explain to them because maybe they're not clear about site problems. This is everyday's problem. Every engineer faces this, and designers are not clear. They should demand some information from you. That means both should sit together and discuss. This is where I say that designer has also got a relation to site person, and site person has got a relation to contractor. These are in chain of construction, chain of production. All engineers from civil, from electrical, from mechanical must be related to designs as well as to contractor. Because without experts' feedback with each other, reciprocal feedback, you cannot produce something which is directly applicable, directly executable. That buildability, that constructability based on reliable design is very important. That is what a major part of management. We are talking of quality. This is part of quality, which we miss. We have egos here. I do this, finish. I have decided, follow it. Follow it means what? Means what? Follow it. Why don't you say coordinate it? Coordination includes leads and follow-up. It simply doesn't say, I have done it. If you say, I have done it, you have done it means what? It is for project. It's not for me also. It's not for contractor also. It's for project. It should be project worthy. Did you think that it's project worthy? That point must be a part of involvement in designs and site. Sometimes what happens, you get some details, some drawings, and you say, what sort of design it is? What this design engineer has done. And you don't even think to talk to that person. Because maybe that person sitting in England, you are in Gulf or you are in our country. So you say, oh, that person cannot understand me. But when that person is somewhere near vicinity, can't you go to that person and talk? Or can't you call that person to your site and see this problem? That is where management plays a role. What happens? Everybody does its job and throw it. Oh, you take this and do it. And does you take your contractor to do it. And God you take and you to foreman to do it. Everybody shares the way. Everybody ignores the responsibility of coordination with each other. And remember, coordination is very important in physical work. We are not giving political speech. We are not talking something. We are related to material world. We are using material which we cannot isolate later on. It's not assembly. It is inclusion. There is a difference. In assembly, you can deassemble. You can reassemble in workshop or in factory. But when there is inclusion, it's different term. Maybe you know or don't. I don't know, but I just repeat: inclusion, permanent inclusion. Permanent inclusion means something which has gone to building or to structure or to whatever is there, whatever project is there, it cannot come back. That is inclusion, permanent inclusion. And their assembly, for example, assembly of scaffolding, assembly of formwork supports, and preparatory work and temporary work, we call them. These are called temporary work, means that can be taken out, removed after activity is over. And preparatory work is that which you prepare for something, you do something and remove that. Just like form work is preparatory work. You have to do form work, pour concrete and take it back. But steel reinforcement is permanent work, concrete is permanent work, column beams and complete structure is permanent work. because we cannot withdraw, we cannot take it back. So it's called permanent inclusion. So when we talk of permanent inclusion, it's very significant item. There is no one who can, you can demolish that, that is different. But when you don't demolish that, it's for use. It is permanent, means permanent for decades, permanent for centuries to come, if it's properly maintained and retrofitted from time to time. Otherwise, it shall also limited life. Car is called permanent for 5 years, not more than that, or 10 years. Your television may be 5 years permanent. Your mobile may be only for 2 or 3 years permanent. After this, a life is over. They call lifelong means 3 years long. They don't say 3 years, they say lifelong. They cheat you and you accept that term. But we are not cheating here. Everybody knows this permanent. And we know we guarantee only few years. For example, roofing activity. In modern world, it's called waterproofing system or roof system. In flat slabs, I'm not talking of in pitched slab, pitched roofs. It's guaranteed for 10 years sometimes, for 5 years sometimes. And they say this is our guarantee. They know that this material shall not decay within that period, so they guarantee. Same thing, other producers guarantee, beneficiaries guarantee your television for 1 year, 2 years when you buy it. After that, they know for 1 or 2 years there will no problem. So they do it from their business point of view, but you are not business buyer, you are user. You feel when you have to pay again for maintenance, but this does not apply to your structure. Your structure has to work, has to serve for decades together. Here, different consideration. Concreting may require 2 hours, 3 hours, 4 hours, 10 hours, 24 hours for big slab. But its use will take centuries. This means if you take in a scale 24 hours concrete and 24 years of use, let's say that 24 years or 150 years, what is the scale value? Don't you respect that scale? If you want to inspect defects, you must inspect defects in construction, defects in placement of reinforcement, defects in form of alignment, form of lining work, pouring quality. Should you not care about that? Because you cannot withdraw. That point you must understand. You are inculcating something into that material, into that element of structure. You cannot withdraw it to reassemble. But machine state is different. Electrical connections can be replaced, but your reinforcement cannot be replaced. Your concrete cannot be replaced. Defects can be corrected, minor defects that too. There is a porous concrete, you can chip it out and replace by some chemical or by some micro concrete or some other material available according to standards of manufacturer, that too not from specifications. And that also very specialist application which you must get consultancy of that manufacturer, but here you won't get. I meant to say our work is very different, particularly civil engineering construction work. It must import that value, though it does not, formally does not import that value, but it is valuable. Nobody condemns that. Nobody can condemn that. People use it and recognize it, that this area has been developed. When they say this area has been developed, means what? Means there has been some developer. And who is that developer? That developer is you. It's you. It's contractor. It's builder. You are developer. Your worker, that is developer. Your foreman, that is developer. That point we must keep here. That it's not that money person, without your involvement, there would be nothing. And this is a fact. So we have to recognize self work, Self-esteem, I don't care if somebody else is dependent on you, no need of any recognition. That person cannot run away, irrespective that person recognizes me or not, I don't care. That person needs you. So your society is that person. Your society needs you. They don't say you are very good. No, no, no problem. Don't say. But we know we have to do it. Whatever they see by eyes is not a fact. They know it well. But they don't know details also. Means we have to work a lot as engineers. We work a lot, we know it. We work in thinking, in conceptual of schemes, we work in pre-design, we work in designs, we work on execution, we work on maintenance, we do everywhere, we well know. But question is, we are not clear. We are working in fractions. We are not linked together. That's point here, which I am explaining regarding management. Is what is management? Management is amalgamation of these activities into one chain, and this chain must be continuous all time. This must not be broken. But we are considering everything in isolation. That is a problem. We have designers, we have workers on site, we have planners, we have quantifiers or quantifiers, and we have supervisors, we have quality people, we have business people who are busy in marketing. Everyone we have in chain, but we are always delayed. We are always delayed. Estimator doesn't consult side guy doesn't care for that. This is my job. Planner doesn't take every information, just plans is according to his experience. Quality guy thinks my job is only for inspection. I don't care how you're doing. There is where lapse enters. That is where you can say kind of disease, I can say. This is a kind of disease we earned. Where it should not be disease, it should be activation. It should be a perfect activity. That activity we don't earn. But now it's time that we have to change our attitude. We have to concern ourselves as changers of society. Engineers are usually called changing agent. Change agent. Engineering means change. Itself is a change, because if there is no change, there is no requirement of engineers. Everywhere there is a change, so you are required, scientists are required. Both are interlinked. They do something according to science world, and we do ourselves according to applied science world. Both are same, no difference. We are more calculative, they are little thinkers. More they think in the different way, we think in operational way. They are basic thinkers, we are operational thinker. So there is a relation between two. We try to sort out which method is best out of 4 or 5 methods, and content try to sort out one which method is best out of 10, maybe double than what we think. But this must come from original thinker, that should be designer, because that person is going to tell us what you have to do. And if he tells based on my thinking, contextual thinking, or practical activity thinking, then design can be best one. I'm not saying something against design, but I am supporting design that is easily operationable, easily implemented. That is best one. It should be material wise best, it should be size wise best, it should be properties wise best, and it should be helpful for work. Work should not be defeated because of design. Quality should not be defeated because of design. And because of work, designer has to learn. It's not simply that I have assumed something. You should go to site and see what problems site guy feels, because site guy is not that powerful who can communicate every detail to you, because those who work on site, they are not very good in writing, they are not very good in expressions, and they are not qualified for that, they are skilled for that. Even engineers can't write explanatory notes because of their lack of skill, but they have to improve that skill. That is required. At least there should be one person that may be called coordinator, or you may call in whatever position. That person should have capacity to make good communication, satisfactory communication to everybody. That's purpose. That's only why. That's only job description. We name that person coordinator. Coordinator is an experienced engineer, experience in science, experience in engineering, and experience in writing and thinking and further writing. That's what I mean to say. We have all classes of people, and planner itself is very significant. Planner, or you can say scheduler, that person cannot work if doesn't have complete feedback from everyone. Procedures must know, specs he must know, quality must know, every every criteria of every factor of management a person must know. It's not simply that one has to draw a bar chart or CPM or part and say that I've done it, follow it. Again, same point comes. I just remember one case. There was a planner, young planner. It was a building, good excavation was done, everything was done. That person took only 4 or 5 days for backfill. I think 3 days. That person took 3 days for backfill. My wow, reviewing that bar chart, I pointed out what you have done. You cannot do it in 3 days. How can I do? You explain to me. You explain to me first. You have taken into bar chart. Did you understand this? What is backfill? That person could not answer. Oh, it's only 3 days I've taken. You are not able to do this. Don't raise this question to me. You question yourself first. I know you don't have experience. That's why you have taken 3 days or 4 days. You are young. You are planner. You don't have experience. Then on what basis have you taken this? That's a reliable question. Standard question. You just took thinking you are in office. Take a line, write 3 days is okay. Only backfill. No, my dear. Go to site and see how backfill is done. You are thinking I have excavated each column there. I have not excavated each column. I'm not fool. In modern world, you cannot excavate independent footings. When there's a machine excavation, you need complete excavation and then found on that all your structures. Then backfill. Because machine can go in, trucks can go in. Don't you understand technology? You are a planner. It would take months sometime, weeks sometimes in backfill. Say it is 2 meters excavation and you're saying 3 days for backfill. How 3 days calculate? If you take 150 layer and it's 2 meter deep, how many layers are there? Maybe 15 layers, maybe 10 layers. Did you calculate how much it takes for one layer? How to do that? What test is conducted? You did not take into your consideration, just you said this. What I'm giving is a reference how people work. So if you don't have feedback from site persons, you may be planner, you may be designer, you may be quality person, you may be safety person. You have to collect information, and that to practical information, not imaginary information. Sitting in air-conditioned room and thinking I'm working. No, it's not right. I have an example in my city. They consider stations where they should be. They did not take into their plan these metro stations. They place 1 kilometer this side and 1 kilometer this side, and we have to walk all that distance. It's not at real point because they never come to site. They never visited that area. Just in office. Okay, put one here, put one here, put one, and that's done. This is problem with our community. We never see practical as we never visit site with that. Means you go and see. You are an engineer. Who will go in your place? You know job. Even you don't go to see excavation also. You just give a design because somebody says this is bearing capacity. It happens. And if you cannot go to site, you cannot even excavate a pit. Even if there's a pit, You can't go and see that. Okay, there's no laboratory, there's no investigation, but you can at least assess the strength of soil for you. No, no, this another building, they did this, the another building, they did this. You are having imaginary references which are not real. And you are taking that one also. So a mistake is copied again, another mistake, and that's copied again, another mistake. A mistake becomes a cumulative mistake. I know there's you don't have material testing laboratory, fine, you test yourself. You can test yourself. Don't test particularly according to specifications, according to codes, but according to your own experience. You can understand what type of soil is that. Can't you do that? Can't you analyze that on site? Can't you take some sample of soil and put in water in a glass and see after a few hours what are layers coming in? Can't you do that also? I don't understand. I don't understand why can't you do that? It's, well, you may be, I don't know, maybe you're getting or not getting. It's something very practical I'm talking about. Last time also I talked that one. I did not take. It's very important one, means something we have to clearly understand. Let me hang on 1 minute, please. I cannot find that sometimes. I got it, yes. Can you see this glass here? This is a glass. The soil has been dissolved in water. You can see upper portion, in between, and you can see different turbidity, different composition, particles in suspension, as over here. You see bottom layer, bottom course. Then go to next one. This is after settlement of few hours of this clay soil. So there's some clay, there's some silt, all particles in suspension. Means settlement is there, some layers, some suspensions. All these are there, which tell you something. And I'll say some other answer here. I will open this calculator. I'll show you something, of course. See quality here. What sort of work is done? You think this quality work here? This was done long back here, maybe a few months back, by Smart City company. And you can see standards of work, how they do it. This is trench for storm water. And you see what sort of quality, what sort of workmanship they adopt. This is complete. If you agree with that, fine. If you accept this good work, fine, it's up to you. But I'm just trying to show you how we do in field. If you call it quality, if you call it structure, well, that's your choice. My purpose of this photograph was to just, I put these photographs on their website as well, but they did not please with this. They deleted all that, Certainly they deleted, and well, no problem. It's nation's property, it's public money, it's public use. You can see that how this is broken here, and then you can say this. You see how surface treatment they do. Just bad surface they cover with just mortar, something, and you can say I'll show you something else here. You can see what type of steel, and there's no fill up, nothing, just the for sake of doing, and they will not treat any further. Poor the concrete issue. What sort of support is shuttering is there? See, there are gaps and everything is there. You see this. Then nobody will take care about this. Let's just put, you see, this is what sort of shutters. You can see that patches of timber, pieces of separate timber. That's what I'm trying to say. And you see this, what these covers are. These are the horizontal covers on that trench, and this is the status of cover. You can see how it's finishing, how they're putting in that, and maybe it's not curing, but you see joints, what's gap. Yes. I just took them from there to just to help them, but they're not interested in anyone help. And I'll show you this one now. You can see this. This is formation level here. Formation is person standing. This formation level, you can see this LNTI, this LNT person. And you can see impressions on soil. These impressions are of foot, shoes. And if there are impressions on soil, what does it mean? And they will do concrete on that. This means there is no compaction done. You can see these impressions. No compaction, no need of compaction. Just to do it. Just to do it for sake of doing and do job, finish. Work is over. Get payment. And you see this concrete? This is blinding. They are doing this type of blinding, you can see. No, on that same impression, they concreted. No need of compaction. Let God take off. God shall do compaction for them. Because after you lay concrete, concrete will compact that. That is what thing. This is what our culture is. And you can see this finished surface in smart city pavement. You can see finishes, what type of finishes and what type of joints are these. Even a person who doesn't know anything about engineering can understand rubbish surface. No, nothing done according to requirement. This is a new job. And see how this edge works, this walkway edge. This is standard of work. This is our standards of work. You see what type of joint it is. You find this is okay, it's your choice. I don't object that. If you think it's okay, I'm wasting your time, fine. You may think that way. See, see beauty of what? How they do this. What standard? How this workmanship of reinforcement? You can see yourself. This is a trench left done, but there's a continuation of that. And or I know this continuation of this is stop and here, but this is the standard of work. This is what they do. You call it management, okay? It's up to you. You can see not one location, every location is same. Every location is same. It's as if there's no value of steel. This free material, they do use it. Everywhere it's same. You can see this type of quality. This not solved for this. I'm just trying to show you quality of work done. You can see how stone is steel. just lying, rusted completely, lying a road. See, there's no base, no support, just lying on soil. You can see this quality of finished surface, how they finish. You can see that cracks, disconnections. This is international company, LNT. Openly I'm saying, why should I hide? You can see beauty, new work it is. Concrete is falling. This is new concrete. Concrete 2019, 2020. This concrete. This is international work. This is another one. Missing, breaking, putting soil on that. Just loading for nothing. Not at one location, many locations I have taken this. See, you see, steel is seen after concrete is broken. This is what we do. An LG is there, you can see that. Broken in, fall, fell in. And how they precast. You see stand of precasting. How steel is lying in LD store, you see. This is a professional way they are using, this is a professional way. My goodness. This is their professional way of L&T company. Just dumping in as if this is nothing. Newly concrete, and this is what they just load it as if it's done. It's 5 years old concrete. And you see how they work. Well, I just tried to show you all that. I just tried to explain to you how we live and how we work here. I just tried to show you quality of someone. Of course, I have taken name because they are working there, and I have every right because they are spending public money. This is not their house they are building. Crores and crores of rupees are being spent on infrastructure work of rainwater, stormwater, and this different design. Don't know what actually they want to do that, but it's one example. There are many examples. No need explaining that you can go yourself and see if you are interested in your country. You can see projects which are done around your city, your area. I don't think we'll find something different. It's in this work. I have experienced big projects also. There's no difference. So I understand now that it is culture of work. It's not failure of quality, but failure of culture. Engineering culture, administration culture. Administration can't be blamed because they are not professionals. They are not engineers. I don't consider them professionals. They are just supports for file movement, nothing else. But we are not file movers. We are work movers. We are material movers. We are we are actually manufacturers, you can say, because we are using material which is manufactured by others as well as which we manufacture on site. You may call it manufacture or construction, whatever you call it, doesn't make a difference. Term only. We are we buy material or we procure material, completely natural material. It may be rock, it may be aggregate, it may be sand, dust, water, whatever it is, and we use that one in proportion ingredients and then mix and use. So that is very important. Stays in management, which is related to design, and that is where we have to talk of. And this management which I have concentrated upon, that is ISO 9001 to ISO 9001 2015, and I have discussed with you about that basics in which form we have to maintain our company, our organization, or ourselves, and that is where we have to value in. I'm not saying that that's perfect one. I never claim that. It's not perfect, but it is acceptable to some standards. They just guide us what we have to do. They cannot force us. No one can force someone. If you want to accept them, it's fine. You can regulate with their support. Or if you want to make your own system, then you will be given less commercial value, but your work will be okay. Your work will be well. It's not mandatory for competition purposes, for participation purposes. You have to be a part of that certification, which is supported by ISO 9000, but you have to be compliant to that requirement. If you are in commercial world, if you are in competition world, or if you are working on your house, you are constructing your house, I don't think that's essential. Then you are your system, your engineer is your system, your professional is your system, you are your own system. The question is quality, whether it comes from your own management or it comes through some system like Aristotle Sigma, or it comes to a Sigma. I don't trust in this case. I'm not saying the Sigma is not trustworthy. It is trustworthy, but it's not, I think, it's not meant for our construction. It's meant for manufacturing of parts or something else, because they say 3.5 defects in 1 million produced items, and I think this is something not you can say reliable in our line, in our profession. Means in millions you have to have only 3.5. Such scale is little fictitious for us. First of all, millions means you have not million products until you count every steel bar, every aggregate piece. Every aggregate piece to count, then it will be stone aggregate, it will be fine aggregate. Can you do that? Every piece of steel means cutting, bending, fixing. You have to count that. In that case, you can reach millions activities. You have one truck of aggregate. How many pieces are there? Can you find that? That is considered. This is fictitious. So we leave it apart, leave it to manufacturers and mechanic other people. But our is only system we understand. We do not count pieces there. This doesn't mean anything, because we have elements with us. We have to produce framework. A structure is a framework. it's a building structure, or it's a bridge structure, or it's a dam structure, road structure, pipeline, whatever, plants, facilities, foundations for machines, all these are structures and elements. So we count that one unit. We count building system, anatomy of building, framework of building, mechanism of building, that is unit. And that's what they say in design. So you have to design this considering as a unit, and if it fails, whole unit should fail. That is basics of philosophy in design, that we cannot design columns separately, walls separately, beams separately, slabs separately. That is not approach. That is only for purpose of learning, just to understand how these elements of course perform. From that philosophical understanding, mechanism understanding, we learn elementary design, but that is not for application. Application requires complete understanding of mechanism, including foundations, substructure, and superstructure, all types of actions, dead load action, live load action, wind action, earthquake action, and whatever other thermal actions are. These are considered in one way or other way, and then we reach some conclusion that this is best approach or that is best approach because of various stresses we find in that calculation, in that analysis. So it is something different. You know, it's like a stool. You sit on a stool, small stool, maybe 130 cm by 30 cm stool, and maybe 30 cm, 40 centimeter height. That is also a small building, you can say. If you just ask someone to make a stool for you, that person shall take some timber pieces, erect them, some small piece of ply, put on that, and in at bottom level some plies. That is a kind of building. If we take that concept in mind and think accordingly, how we balance our stool, how we balance our chair, how we balance our table, you can understand what is building about. Building is also a machine. Building that we design, that we produce, that we construct is also a machine. It's a mechanism. Machine means mechanism. Machine is designed based on certain mechanism. So building is also a mechanism. Building basics floor is building workshop floor is soil. So soil is also a part of mechanism. You cannot condemn that. Where we may consider we take it separately in designs today, but practically it's a point that it's a part of structure. Why do we consider this soil as a part of structure or support in machine designs? We consider there, but not in building designs, because we consider it's negligible. And we take factor of safety on that. Yes, you are right, you can take factor of safety, but it performs. If there is no soil, how can you do that? How can you do that? Now let's go to some other way. We are sitting on earth. This earth is a planet. We are sitting on this. This is our foundation. But where is earth sitting? We are sitting on earth. Everybody of us, every building, every road, every person, we are all earth. Earth is our carrier. But where is earth sitting on? On which? On what? Same planets, all planets. Where are they sitting on? Nowhere. They are not sitting. There's no base, but they are not failed. Since time they were delivered to us in this system, solar system, they haven't failed. They have been working for, I don't know for how many millenniums or billions of years. Nobody knows, but they were working. Because there's some force there which is keeping them in dynamic equilibrium, in vacuum. There is a technology somewhere which was generated that time. Can we imagine that? We do a lot of work for designing buildings, for roads, for airports, for other, which are this earth is carrying. We do a lot in that for designing this carrier earth. What How much calculation might have been done by God? Just imagine. This solar system, this is one solar system. I don't know how many would be there. I'm just trying to tell you what is value of management and design. If this planetary system with different diameter of balls, different speeds, different velocities, it's working for us. That's when that too perfectly. Have you ever thought of with what speed this earth or this solid part of earth with air is moving all the time? Did you ever calculate? I think maybe none of you calculated this. But shouldn't you think of that? If you have studied geology, you must have some information about that. Maybe. Or by general knowledge. Say 12,500 kilometer diameter sphere it is. On an average, I'm not going to exact figure, which I studied in geology because I opted for that in one subject. There are three subjects for options. So okay, I prefer for this subject. No problem. I like to have this. I got information first chapter itself. This Earth size is this 12,500 kilometers. So I think that I should know its speed on its axis. It's rotating all the time. Yes, it is. So I calculated it comes around 1600 kilometers per hour because 24 hours we count as day scientifically. So its diameter, circumference, and division by 40 gives the result that is 1600 say kilometer per hour. So we are moving in, you can say, high speed plane. Our international flight is only maximum 900 kilometer per hour at height of 10 or 11 kilometer. You may have traveled and known about that, not more than that. 900 kilometer or little more in long distance flights. This is 1600 kilometer per hour. Is it not worth to research on this and then forget this? We are moving on this earth around sun in orbit. Around sun in orbit, we are moving and completing one orbit in 365 days. You all know that. So we can calculate it also. We have size of sun with us. We have distance of sun from earth, which is around 15 crore kilometers. Everybody knows that. And size of sun I have taken from some reference. This is 1.3 million kilometers. 13 lakh kilometers is size of sun and 12,500 kilometers size of earth. Just see difference. 12,500 and say 30 lakh. How many times it is? This was a scale it is. And we are moving around that. And if you calculate complete circumference of that and divide by 365 days and hours, you shall find around 1.25 lakh kilometer per hour. 1.25 lakh kilometer per hour. You are moving this earth around sun. You calculate yourself. I have put a file in one video. You can go through, see. In economics, I think somewhere in solar system, you can find there this information. This is very interesting information. Means we do not know that we are using these two speeds to stay in dynamic and motional equilibrium. Self-dynamism and the rotational of in orbit we are moving with this speed. You never thought of that. This means you are in space. Your earth is a part of space and we are moving in space, and all planets move accordingly, rotate accordingly, dynamically. This is just a reference I am trying to give you because you are all seeking some knowledge. Maybe from books you may not get this, but your thinking would bring you that one. So I try to calculate it for all planets, and I got some information that actual sheet. You can refer to that if you are interested. Only as a part of learning management, I can say it's not that project management, but informative management that we can understand. So it impacts on our raw materials. on our natural resources. When earth moves like that, means there are some forces somewhere which are moving that. And that's what we call metamorphism of rocks. We call some of the weather creation, weather turbulence, pressure development, everything. Value of sea, value of that. Just take for example sea. That's also a point to learn. What is sea? Means if you ask some person who doesn't know anything, they will say some. I asked this question to someone, he could not know. Oh, there's water all around. Earth is living in water. Earth is working in water. Some confusion somewhere. Somebody calls something and somebody calls something else. There's a patal lok, there is this and that. You will find all the deceptive answers from everybody who knows nothing and considers the expert of everything. Pundits and leave that aside. But thinking technically, what does sea have relation to continent? Because this is a part of engineering. It's a part of understanding how mechanism works. We may say there's a plate tectonics, there's a this and that, but what is sea and what is ocean? I understand that sea means a water reservoir, a water source up to 4 kilometers in depth, maximum 4 kilometers starting from beach or shore down gradually to 4 kilometers and ocean to 10 kilometers. This is specification which I understood from some book. I'm not sure, but this information I extracted from there. 4 kilometers you take sea, and now think as an engineer, what is pressure of water? Pressure of water is 1000 kilogram or 1 ton per square meter or 1 per cubic meter, you can say. Weight of water is 1 ton per cubic meter. And we consider in hydraulics or in fluid mechanics, that's 1 ton per square meter. So 1 ton per square meter is pressure. So when you reach bottom of sea, which you will not reach either practically, but let us say we have reached there. So what is pressure on us? It is 4000 ton per square meter. 4000 ton per square meter. Your small table may be 1 square meter, small table. If you put 4,000 ton on that table, what shall happen to your table? And if you go to ocean bottom, it's 10 kilometers, there will be 10,000 ton per square meter. So just think on what shall happen to rocks there. Because rock must be there. Can the rock tolerate this much pressure? Yes, if it's solid, there's no transfer of pressure. We know solid is consistent. There's no transfer of pressure in solid. But water is not solid. So what shall happen at that level where it's 4,000 ton per square meter and 10,000 tons per square meter? What shall happen to that rock, which we call basaltic rocks or basalt rocks? And if the creatures are there, fishes are there, faunas are there, all these created, all this population of sea, what shall happen to that? How must be they surviving? We should think about that. Can you tolerate that pressure? This means rock cannot tell. On here, on crust, which is just near ground, you will find rocks which are having 10 tons per square meter or 20 tons per square meter or 100 tons per square meter. If it is igneous rocks or it's sedimentary rock, igneous I mean to say volcanic produced rock, volcano produced rock, and other one is sedimentary, that is settlement or sedimentation produced rock, and metamorphic rocks. Sedimentary rocks again, but due to chemical actions, applications on that, it is converted to some other state, that marble or something like that. What when on ground it happens due to metamorphic action or climatic action or whatever temperature action, what would be state there at bottom of sea, where from we extract our raw oil using our sea platforms, rigs? Means you will not find solid rock there, certainly. You will not find solid rocks there. All salts must go up from there. All salts from this rock. So sea water can be called saline. That is the reason water is saline, because all sulfates come out. All you can say chemicals come out at that depth. and this mix up in this seawater, so it results in salt taste. But this is completely dense water, you can say, dense soil mixed water, dust mixed water, rock mixed, because this is crumbled rock. From where we take out oil? Little beneath, you go little beneath, you will find fossils fuel there, which converts to oil. We get up to surface and move it to refinery. That's what it is. Means you imagine you can't stand at that point. Forget ship can go there. Forget ship cannot go there. The buoyancy effect will not allow that. That is what I try to say. That management does not stop here. Management is not limited to just few chapters. It's a vast chapter. Economy is involved in this because we are spending money on projects. We are using natural products. Steel we are using, rocks we are using, dust we are using, and aluminum we are using, iron we are using, and timber we are using, and many more. Not one, not two, all. And where from do these come to us? That's another point. We explore, we mine, and get these materials. This means mining is also related to us. Exploration is also related to us. Ores are also related to us. And processing is also related to us. So where chemical engineers are involved, other engineers are involved, and production engineers are involved. And we all get materials through their services. We cannot ignore them as well because we are using their material. Reinforcement steel we are using, iron we are using, stainless steel we are using, aggregates we are using, water we are using, machines we are using, what we are not using. So indirectly, those are also our supports. Those people are also responsible into our quality criteria. If I don't get quality material, reinforcing steel, carbon steel, or epoxy coated steel, or some other steel, or some other form of cement, I cannot produce working quality. I cannot produce performing quality. So quality does not stop at my shop, at my level. It has to move further. It has to come from some other source. So none of us is in fact at origin. We are either on negative angle, a negative, or can say this end of x-axis or that end of x-axis or y-axis or z-axis. We are somewhere located and other guy is also located. So we have to be somewhere in some tune for a part of job. So if I don't get quality reinforcement or steel bar, I cannot get good material, quality material. I cannot take good fill material. I cannot get good timber for my doors, windows, or steel or iron or whatever it is I'm going to use. It's not possible to get quality product. This point only we can understand because economy to some extent is a part of engineer. Engineer always says economical criteria is very important. Yes, but we have two types of economic criteria. What is financial economical we have to be, and other one is material economical we have to be. What does it mean? Material economical. We are using materials. Every material has quality. It has compressive strength, tensile strength, torsion strength, and it has some other chemical composition strength. And also this is not permanent. This keeps on changing, and at one stage comes when it converts to hysteresis loss. Means it gradually weakens and weakens and weakens, and what has come when there? You cannot rely on that, or you can say there's a stage has come. We can say it enters into plastic stage or yield stress or collapse stage. That property of material we have to realize, but it may take years together, decades together. But you have to understand now, because this is material property, so we have to use it in a way we optimize its property, optimize use. so that it doesn't result into hysteresis, or it doesn't result into collapse condition or plastic condition, which shall weaken its life. Because its life is not independent, it's related to another material. It can impact that material. For example, concrete can impact reinforcement. Mortar can impact brickwork, blockwork. Flooring can impact on its own components. So this point we have to realize in different way, not in simply what people define. Economy is a part of engineering. I'm not talking of macroeconomy. I'm talking of materials economy and quantity. If we have material, we can use it. If you have quantity, we can use it, we can test it. And if you don't have that, we can't do anything. We get material from different sources. We get cement from one source, and cement person who manufactures cement, that person gets silica from some source, limestone from some other source, chemicals from one source, PFA from one source, GGBS from another source, microscope. So that person is also in a net of various material supplies. Every manufacturer who delivers us something, that is also interneted, and we are interneted with all. So our management is wide net. It goes from ours to manufacturers and manufacturers to earth, because we are getting materials from earth's crust. Forget mantle and forget core. Earth crust itself we are not using properly. We are getting food from plantation, so that is also a source. Complete plantation is our food, and complete earth's crust, internal, say up to 2 kilometers, 1 kilometers is our resource. Mining is not done up to 10 kilometers, done only hardly up to half a kilometer, because it's not possible to go further. We are not so strong till now, we are not so prompt till now that we can construct a room at 10-kilometer depth from surface. That's not possible. Yes, we can move submarine in water, sea, but in continental part we have no access yet, except some meters from surface. So we have to just realize what distance we have traveled in our technical development. We have not traveled yet. We are just trying to understand what is that. We are just trying to use electrical wave flow through these rocks and understand what sort of metal there is, how this behaves, how this strata can conduct. Only that we understand. So my management criteria says that I am not isolated one. I am not in wood alone. I am in wood, I am in city as well. If I am in construction, this doesn't mean I am isolated. I have to depend upon all others. This means management is different. It's not what we consume. I have to be perfect in knowledge about what is coming in. If I am getting aggregate stone chips of certain design for certain grade, I have to be sure about that. Which I mean to say, quality control criteria comes into action that time. I have to test full range of that aggregate for my trial of concrete. I must know what sort of properties this stone chips, people call it aggregate or whatever, this has. What is size of this material? What is interlocking property of this material when one interacts, one locks into other? What is size of longest particles, which we call elongation index? We have to see what is its degree of erosion with each other when both chips fight with each other or rub with each other. All these we require to understand. It is granite, we call it igneous chips or particle or aggregate, or it is sedimentary aggregate, or it is metamorphic, or it is sand, or it is soft. Whatever it is, that property we must understand. And until we understand, we cannot be sure what real action of this product would be. And of course, there is heterogeneity in every material. Materials are not homogeneous in texture, in volume. These are all heterogeneous. Even your steel reinforcement is not exactly what it should be. There can be chemical composition variation like carbon variation, like you can say heat treatment variation. There can be, and they may call it anything that is commercial sale. I don't trust that. We are also limited ourselves to tension test, to all that elongation test. All this we do, yield stress. We are also limited to that, and we never concern about cement. We say, okay, this is fineness, well, this is fineness, and this is this, and this is that, 3 or 4 points, and we conclude that this is acceptable. We conclude, we test full range of this aggregate and say, okay, this is fine. We have got fineness modulus, we have done this, and this way we conclude everything. But nobody bothers about real action it will give, fruits, or you can say fertility of material it would give. It may be futile, but you consider it fertile. This means we are in a world where there is unlimited access and unlimited exit. You can in and go out, regress, but you have to depend upon that. We are going to use PFA in cement, we say, because cement is never used alone nowadays. Previously, it was used the OPC and somebody used SRC. OPC still some people are using because they do not understand what they are doing. SRC was also used. OPC means ordinary Portland cement, and SRC means sulfate resisting cement. There were these two brands for long back. OPC is cement, that is means this pure containment of limestone and silica. These are both natural materials. Limestone is something else, calcium carbonate, you may say that, but it's not pure that one. And silica, it's kind of sand. So this is a combination of rock material, which is, and limestone is not rock, it is different type of rock. It's a sedimentary rock, you can say, which is converted to limestone by metamorphic action. So you are getting, again, same problem, limestone and silica. One is different family, silica is not same family as limestone, but both have to stay together. Only then you can work. So we get cement from that sources, of course, some more chemicals in that. That is OPC. SRC is having some more chemicals in that, aluminum sulfate and this and that, tetra and all that, there are the chemicals. This means we are still depending upon old contemplation. Now we have added, say, PFA into that, pulverized fuel ash, to replace some portion of soil, cement from that bag. And we say, we claim we have replaced 15% to 25% cement by PFA, and we are happy with that. Okay, you are happy. But PFA is also a limited use material. It cannot give you what you want, what you expect. Can't give you that. There's a limit to grinding of PFA. This limit to its financing. You cannot make its varying use. It works to some extent. It can enhance initial setting time of cement, of course, to some extent. And I am sure not more than 1 to 2 hours you can enhance setting time of cement. Even now, what I am saying, you have to depend upon such materials. There's another material that is GGBS. I have explained many times. Ground granulated blast furnace slag. Ground means ground. PISA, granulated into granules forms blast furnace slag. Blast furnace in, where it is, in iron manufacturing, and slag, that is residue, that's a byproduct of that, and you are using that to replace cement. It's very good, because GGBS is short, we call it GGBS, and this is very reliable material. If it is properly manufactured and ground, it helps cement It's not cementing material, just like PFA is not cementing material, but it adds cement. It assists cement to augment its properties, to enhance its properties. I have put a note on GGBS somewhere. You can go and see that in some video of that one, because GGBS is helpful to some extent. Let me say what it's helpful for first. You know, cement, OPC, it is very good in generating carbon dioxide. Maybe you know it. 50 kilogram bag of cement, if it's pure OPC without any PFA or without any GGBS, it can help you receive 46 kilogram of carbon dioxide once it works in water. 50 kilo cement can help you receive 46 kilogram of carbon dioxide. You just think how much feedback of carbon dioxide you're getting in. You're getting rich in carbon dioxide rather getting poor of this. You are getting this carbon dioxide, but you're not capturing that. You are releasing it into environment. This means this is going against the spirit of environment, but you are using it. And how many millions bag we use in a year or in half a year? Everybody knows it, no need explanation. Now if you use in place of 50 kilograms cement OPC, if I say I will use only 30% OPC, that means a 15 kilogram rather in place of 50 kilogram, and remaining portion I use GGBS. That is called supplementary cementing material. I am supplementing my OPC with GGBS or with PFA. PFA is limited in supplementation, so I prefer to use GGBS because I can replace 70 to 80% cement. If I can replace this, means what? This means only 30% weight of cement shall convert to carbon dioxide. 30% means 15 kilogram. Previously, I was using 50 kilogram for production of carbon dioxide, and then 50 kilogram gave me 46 kilogram. So this 30 means 30% only shall give me 15. How many? 1/3 of that or more than? So maybe it is 15 kilogram production of carbon dioxide. Production of carbon dioxide from a figure of 45 or 46 kilogram goes down to 15 kilogram. What does it mean? Does it not help environment? It helps environment because I have reduced, or we have reduced, production of carbon dioxide, which is environmentally unfriendly, but can be used somewhere else if you capture it. But you are not capturing it. It is giving heat and exhaustion and everything. Yes, I have replaced it with GGBS. So now I am increasing GGBS. So what is benefit to me other than reduction of carbon dioxide value, quantity? There is benefit. First of all, GGBS, you can say, it can be ground further and further. Its fineness modulus can be varied. What is fineness actually? Maybe many of you are not clear about this. When you see cement, you take some cement, 1 cubic centimeter of cement, 1 cubic centimeter, and put it on some area to rub it completely, and use that for complete area to paste the cement by finger or something. You will find some coverage of that this 1 cc of cement has covered this square centimeter area of what it is. As much area it covers, that fineness increases, as much it covers, and that is called value of that cement. Fineness is higher, means higher grade of cement, because it reacts that way. It reacts that way. So GGBS, how does it work? It can be used in variation when fineness is concerned. So its particles are more finer and can match with fine particles of cement. So both can be used in combination, which results in shrinkage controls, shrinkage cracks controls. which results in little delay in initial setting of cement, which results in initial delay in strength getting. Maybe what you get in 7 days of pouring by using ordinary Portland cement, in this case you may get same in 10 days, and what you got in 28 days maybe a few days later. But ultimate is same. Ultimate strength is same, but with better cracks control and better durability. That is more important. Rather than worrying about current savings, life cycle value is enhanced. Maybe I would save cracks. I would save cracks means I will save repairs. And if durable concrete means best way, it's more working, it may live long, it may have better protection against forces. There are so many other counts, but ultimately end result is same. You may have spent little more time on farm work indeed, no problem. What's loss in that case? But I am getting improved material to perform. There is no other difference. But you are saving environment. That is most important. 40 kilogram, 46 kilogram reduces to 15 kilogram carbon dioxide, and further move to another material which is also supplementing material, supplement is cementing material, and that is micro silica. You know that silica fumes, you can say. Of course it is expensive material, but it is perfect material, because you cannot use more than 9% or 8% for cement replacement, and that is very dynamic material. In fact, it's like when you smoke, particles of smoke, its size is like that, very light particles of smoke particles. These particles penetrate into cement particles and coat them. Microsilica particles, that's why it's called microsilica. Silica fumes, it is silica smoke, it is silica, which is nothing but soil, sand, our sand. This is silica. So these particles coat cement particles, and this bond which is created by coating of these particles with cement particles remains constant until it's broken, and this remains in suspension. This means all cement particles would remain in suspension until you like it, and once you break them, only then concrete setting starts or cement starts working. So you can delay this suspension even up to many hours if you wish. It's not that cement setting time starts in half or 30 minutes or in 2 hours. No. In case of microsilica, it does not apply. When you vibrate that concrete, then particles bond is broken. Without vibration, it would not. So you can hold concrete even after pouring in for hours. Even if there's a delay of next mix and you did not apply vibrator, you will save your cold joint. It still would work, but only is that it is expensive and you have to manage it. But it is that way perfect. You are going to protect it from chloride penetration. You are going to save it from carbon dioxide actions, and all this would help you other way also. Of course, strength is same, delivery is same, and when you use this material, there is no need of sulfate resistant cement, because this itself is sulfate resistance. GGBS itself is sulfate resistance. So your requirement of a parallel cement is diffused. If you understand this point, this technology, this material property, you can think better. But problem goes to curing. You believe only in flooding curing, flooding water. That is one part of curing, or spraying water and curing. But we have certain foundations which are big. You can say if there is some member which is 80 centimeter in size minimum 80 meter size in sections, I'm telling you, and there's a quantity which is around 8 cubic meter, that member is not an ordinary member. It's not an ordinary one. It's called thick member, not thin. Your ordinary beam is 20 centi, 30 centi, 30 centi, 40 centi, like that, or a column, say 40 by 40 or 50 by 50. These are all thin members. Here I am talking of thick member, which is 800 mm minimum in dimension and 8 cubic meter. This is thick member, and there's another member which is massive size, which is more than 24 cubic meter and more than this thick member size. That is called massive member, not mass, massive. Massive block which is generally used for machine foundations. Machine foundations, for example, big generator machine, big equipment, vibrating equipment, vessels, boilers, washers, compressor foundations, others which are heavy, vibrating or stationary machines. Heavy one, boiler, big boiler. All these such structures, depending upon what type of soil you have, are massive blocks which requires low shrinkage cement, because if you use ordinary Portland cement for that or sulfur-resistant cement for that, this would develop early cracks, air cracks, shrinkage cracks, and we have to delay them because of this massive size. There would be internal cracks which cannot see, we cannot notice. So from that viewpoint, we have to use this advanced materials, which are different type of, which are founded by supplementary cementing materials, and these supplementary cementing materials are PFA, that is called pulverized fuel ash, GGBS, this is ground granulated blast furnace slag, and this microsilica, and could be more. To my knowledge, these are prime materials now. So we have to take all these points into our designs. That is very important. Whether we are going to fabricate in factory as precast element or pre-stressed element, or we are going to work in field as cast in situ element, this point must be considered. And I understood that people are not very serious about this issue. They don't even think what type of metal is, and information is not generally available. They may advertise something which is fake, no relation to engineering, just for sake of sale. These manufacturers advertise, and public believe that, because public got no direct relation to professionals. They don't understand what is use of professional in engineering and in construction, because they are not informed properly, do not have education, and at least information is a must, and they are kept off from that, just like we are kept off and we keep ourselves off. This is what I'm saying, that project management has many legs, many hands, many ears, and every part. It's vast. Everything comes to same point again and again, again, and it's involvement of engineering, involvement of technical exercise, involvement of, you can say, production, involvement of, you say, site work, involvement of drawings work, involvement of coordination, involvement of interconnections, involvement of all constitute management. So this management is completely different than management what we understand. We understand that business administration management is management. That is different management. There's nothing to do with us. Again, I say, our management is different. Our management is generated, it is developed, it is learned by experience, not by just bar chart or by just something. Every technical or non-technical activities that we do constitute management definition. It's completely different. No book can teach you this. You can only learn by your experience. You can learn different methods. Just like I said, these examples of concreting elements, foundation, this thick member foundation and massive block foundation, these are all different, require different types of curing. For example, I said massive block. Ordinary member you can cure your way, which you better feel better water curing or curing compound or covering with your saturated gunny bags or Haitians and then or polythene. That is your choice, or this thick element. But massive block is something different where your flooding of water fails. Reason? Maybe it is 2 meters deep foundation with massive concrete. Maybe same size in width and in dimension maybe 20 meters, 25 meters, big member, where some machine is going to sit on this. Or you say I have to do flood, then how much flood can you do on that? Flooding, how much flooding you can do, and to what depth it can penetrate, and on sides, what about sides? You spray water, say I'm spraying using my hose on that. So what surface it will take in, up to what concrete member will penetrate, maybe 1 millimeter, 2 millimeter, 3 millimeter in 7 days, in 10 days. But what about internal of that? Internal concrete portion, if you just take 5 centimeter cover around just for, and remaining concrete, who shall take care of that? There is heavy heat generation after few days because of quantity of cement, quantity of this material, supplementing material itself. Ultimately, it will react. Of course, there's a delay in reaction, but it's going to react. And reaction means thermal engineering, thermal generation of heat, thermal heat you can say, thermal energy would erupt in. And if it erupts in, it's more temperature than your water spraying outside or on top. It will penetrate out, evaporate. But water has not reached to that level. Your temperatures rising and falling temperatures, if you install there just for observation purposes, you will find greater orientation of this, greater reading of temperatures rise or fall, depending upon time, hour, day, what hour it is, and you have to read those. This means there shall be variation in temperature within that body of concrete. That must be controlled. And if it evaporates and is released from member, how shall you reach water there? That's the question. This means there shall be internal section longitudinally as well as cross-sectionally where your curing treatment fails to reach, that portion shall not gain strength as it is intended for. External casing only shall be water cured. How to treat that? After all, we have to understand what curing is. Curing of concrete is all about. We call curing means just to replenish bad effect of evaporation of heat, and water replaces that. Agree, this replaces. But in this case, it's not replacing. This 2 meters cross section, we are spraying water on vertical sides. It's going only to little thickness of concrete and remaining portion. It's not getting in. So what to do then? What solution as an engineer or as a manager you have? What I understand and I experience that. Curing says protect concrete from being evaporated. Water from evaporate, right? Protect concrete water from being evaporated to outside, the external volume. external of concrete area, space or air. By For that we use water or we use curing compound. So in this case, this means we have to preserve thermal energy. We don't allow that to go out. We want to keep it in so that curing is not affected. So we can say if we don't allow that heat to go out, force it to be in till concrete hardens and sets fully, we can do that or not. We don't allow release of that energy, that heat. That method is done in such members, and that is known as thermal curing, not water curing. Means we go to use thermal energy for purpose of curing. We don't allow heat energy come out, remain there itself and die there. That process is called thermal engineering, particularly in this case of massive foundations, machine foundations, equipment foundations. Maybe we people are not aware of this, but it is done. Means you have to make such arrangements that no evaporation from that member is allowed till curing period is over. That is most important. 7 days probably, 10 days probably. You have to keep in such a state that it is completely protected. This is called thermal curing. You may use whatever method to prevent, to keep heat in, not to allow any release, and that is called thermal curing, which is very important from industrial construction viewpoint, where you work on onshore project, where process foundations, process equipment foundations, vessels foundations, the hundreds of foundations find as such, which require such immense size concrete members, foundations. So this is very big part of management. Means you have to write certain method statements which cover for ordinary foundations, which cover ordinary structuring and steel placement, or which cover superstructural elements or substructural element, or we cover about various other types of methods, waterproofing or protection of foundation members from waterproofing, or massive foundations, or piling or micro piling, whatever these, all such activities which of course work on such projects, you have to keep into consideration. All this must be completely written and explained to those people who work there. And this is also a part of skill development, because you are getting newer materials and you have to understand their properties and then apply. And maybe you have to design yourself sometimes, because we are not getting designs in time for minor materials, minor members, we have to take care of ourselves. So that's what I'm saying. This management is completely different. Completely different. ISO 9000 can give us information only, guideline only of procedures, not of detailing. They tell us only this way you can manage, nothing else. This can you can manage quality only, nothing else. This is quality system management. But why I'm talking all this? This all covers quality criteria. This covers big criteria. And this what I'm telling you because I have learned all this during my career. I have not learned it from books. I learned it from experience. And that is big professor. Your professor is waiting on field, in field, on sites. There you learn because you deal with every person. They are from different nationalities, or even if you're national, doesn't matter, as far as they know job. They know their respective job. Laborers or workers know their respective job, technicians know their respective jobs, and engineers know their respective jobs. If all know their respective jobs in its entirety, they can exchange knowledge with each other, and that is what experience counts. It's not simply experience of being in the field or being in profession, but working and learning and teaching. You have to work, you have to learn, you have to get feedback, you have to understand feedback and apply. And also we respect manufacturer's instructions, which generally we ignore here. Manufacturers means what? Manufacturers means specific manufacturer. It's not manufacturer of tile or brickwork. It's manufacturer of material which is proprietary, means which is patented one. And that is the technology itself. How that material was designed, is designed or manufactured or done, that is a kind of secret. But how it is going to be used, manufacturer is bound to explain to you in details how this must be applied, must be operated, and that method must be given on product itself or its data sheet, which is very important because it is proprietary material. I have no access to your technology. No one has access to your technology. You are not free to grant me license for that. So you have to tell me how to use it. And that is called manufacturer's instructions. Because it is technology. It's not simple instruction. You are bound to tell me because you are going to warrant that material. Of course, you would write that site is not in my control, use of this material is on. Okay, fine, you can write that. But if I do this, if I work on this material according to your instructions and prove that, then you are perfectly bound. So I must get that information from you in every part, in part of its subject scope, in parts of its safety management, in parts of application management, and then its results and aftermaths of that. And if I keep all these records, then you are bound to take responsibility of that material without saying that it's not in my control because I follow your instructions. So manufacturer's instruction also constitutes very responsible management, which includes with my management and inserted in my project. There can be many applications, many materials which are used like that, waterproofing for example, and other items that I say is this supplementary materials and some other materials like chemicals, many materials, warranted materials. There are so many materials which we have to learn use of, and it is a part of education because they are experts. They would tell us use it, do it like that. That is what we have to concentrate on. And more concrete is one element. It's only one element. Of course, it is massive one. It's a quantity, big quantity, but many other materials are there, which we have to understand. There are different ways, means confusing ways are there. And we have to discover that. We have to control that way. How it is confusing. We have to avoid that confusion. And not only from this, from each and every point of view. I just example one was given to you. Again, I say concrete block, for example. We all say we are using concrete blocks, hollow concrete blocks. This 40 centimeter size of the 39 centimeter ordinary standard block, 400 mm finished in placed position is 400 mm, 200 mm, and 100 mm. Whatever concrete block is there, there is some strength designation. It may be 7 Newton, we say, it may be 9 Newton, we say, or whatever other descriptions. We are not clear about this sometimes. We are not clear about this. Which is 7 Newton only, this is very big concrete, or 9 Newton only, very big concrete, or 13 Newton, very big concrete. But this is not concrete. Strength. If you open codes, you'll find something different. That happens. Of course, it is concrete, standard concrete, and they won't explain to you and you don't know, and your item is also not explaining, then what to do? You have to record codes. No other way, because you have to test it. And test guy shall give you strength, total load of this is this much. You have to find strength yourself. If that laboratory technician doesn't give, you have to find yourself. How will you find that? This happens, confusion exists. Confusion exists everywhere because we do not get full information. There we miss some point. That must be clear. Yeah, if it's solid block, it's different. I'm not talking of solid block because solid block is used only in rare occasions, only in foundations when it's required. Otherwise, hollow blocks are only used, concrete blocks. We are using bricks in our country. Bricks is not hollow, it is full, so it's different. Whatever testing weight comes, we have to take full and divide by that projected area and we will get strength. And there is no connection, no difference. But in block case, there's a difference. We cannot take actual area of block. We have to take projected area of that. And then projected base, we have to consider hollow also in that as area. That is fundamental of this. So which is say 7 Newton, and let us say 50-50 is hollow and solid. So 7 Newton actually becomes 14 to 15 Newton. And 9 Newton become around 18 Newton, and then further and further like that, depending upon what proportion hollow cavity and this solid is. We get different designation of result. Just explanation I am giving to you how this works, because I have seen some problem in that. In strength variations, what happens, because these manufacturers have lot work. They have millions or thousands of blocks to produce one time, and they're short of storage space, which is natural. So what they do, just they cure it to only for 1 day or 2 days and try to send it to site. But we are not informed about that. And we take them to test, say, today blocks came, tomorrow, okay, send these 12 blocks for testing. But in 3 days, you think it will gain strength? No, it won't. It would fail. Manufacturer did not tell you when should you test, and you fail in that information. So result is that your block fails. Because you were required to cure that on site. It is not cured in factory. And there's no way that you could apply autoclaving on that. Autoclaving, which is steam curing, which is done on precast members, precast members. You do a steam curing, that's called autoclaving, and that you can say in 2 days time, or because generally it gains strength to such an extent that you can shift it to site for purpose of erection. That is called steam curing. But in blocks, there is no steam curing. They release it for you, and you see maybe 20% are broken on transporting time here, and you receive that. So this is what I'm telling you. And I also handle this on site. There was some tender and was doing that. I was not having complete information. The specific, you have to keep these blocks, only you can use them after 28 days. Means it is given in a specification that you have to use these blocks only after 28 days. Why? And there was a person who argued, no, it's okay, 28 days you need for this. Why should I need 24 days? What is the reason behind that? I am going to occupy my site with these block trucks. Every year blocks and blocks and blocks, and use of my site, circulation of my site hindered. If I test block and it gives good result, adequate result that I can use it, then why should I wait for 28 days? What engineering reason forces me? It's a question mark. Just like we can use concrete after 7 days. You say, okay, adequate strength is there. Block can also be tested. Tested. If I can use it in fifth day, what's wrong with that if it gains strength? It can be used. Why should I wait for so long a period? Am I foolish? Otherwise, what's the use of engineering management if you cannot understand such points? So we got a clarification from them. No problem if you have adequate strength and test corroborates that you can save this time. After all, I cannot block my working area because of these blocks. And not only because of the blocks, with also many other materials which I use on site. And then it's difficult to work. How shall we work? So these are all points that import your attention. If you do not think this way into these questions to solve, you cannot comfortably lead your project or yourself. First, you have to lead yourself. And that's what I am trying to say. Concentrate on information and on documents. Documents must be there from every manufacturer, from every you can say consultancy, what they used in, what method they used, how they support you to explain to you what we should do, and then only you can successfully understand minds, because only documents can tell you what you have to do. Everybody is not present there all time. Document is a medium that tells you you have to do this, and you have to understand that. Otherwise, there can be no virtual office, there can be no virtual arrangement. Virtual is working every day in this world. Virtual office, virtual designer, virtual information. We are pulling in all these informations virtually and using them. So virtual management comes into play, which is different than physical management. Virtual management of materials, virtual management of technology, virtual management and information flow, all do virtual seminars, virtual conferences, of course we want. So we have to little convert ourselves to different kind of management, which is undefined but practical. We cannot stick to what was done 15 years back or 20 years back, that we have to steal ourselves, we have to nail ourselves there. Not necessary. That's what I'm saying. So what management speaks is something indifferent to what we think. Engineer itself is a manager, you have to keep it in mind. Engineer doesn't mean technical only. It doesn't mean technocrat only. It means total manager. When you manage your budget, when you manage your tender, your bid, or you manage your budget on a budgetary basis like consultants do, or you produce feasible report, or you start field working, or specification writing. These are all management job. Exclusively design is not management. That is technical job. But such type of acts are management jobs. Budgeting, which depends on what? It depends on quantification. Pre-feed budget means the budget of policy budget. If you have to decide some policy, you need some information on what money you will need, what funds you will need. So that's the budget. It can vary 15 to 20%, 10% like that. But when you make or when you draw real budget, you depend on what? You depend on detailed quantification. Quantification leads to what? Quantification leads to costing. And with use of rates, item rates, which you get from where? From material rates. So means you get information of market to reach to costing, unit rate and quantity, and all lead to what? To amount, to sum, including with labor resources, workers resources, and various other establishment resources, equipment resources, which are called indirects. All this is management part. Though it's estimation, but it's management. And then site work, which is management. So with this management is completely technical, administrative, operational, managerial, and human relative, machine relative. It's different kind of management. You cannot define it one item. It's totality. Just like we define quality as total quality management, safety as total safety management, this is total engineering management. It's my term, I'm not saying this given some book. You comprehend yourself that you are doing total work or you are doing only work in isolation, that you don't want to include other disciplines, then you will fail. You will not be able to lead. Engineers means a leader in profession. You have to lead 50 persons, you have to lead 100 persons, or you have to lead 1000 persons, or you have to lead a crew of designers. It depends upon where you work, but you have to lead one time or some other time, not in the start of your career, but maybe after 5 years of your career. After 10 years of working, you have to come to lead position, or else you are a failure. If your experience doesn't make you leader, you are a failure. And leaders can't be alone leader at one rank. They are going to be leader of different ranks, different ranks. So my dears, my contemplation of management is not what is your contemplation. It is little varying. It is because of what you think about. I am not saying formal management is not management, but that is not engineering management. Engineering management means only engineer can do it, who has adequate qualification and adequate experience. Others cannot do that. Yes, others can support you. They can support you how to manage human resources, how to manage equipment resources, how to market. Like that, secondary or sequences supportive arrangements they know, they are experts of, but not engineering management. Engineering they do not know, they cannot work on that. So you are there to understand this management. You are there to know about where one should be placed. It's not necessary that a person fails in one state or one status, one appointment, and you know what person is, but you fail to understand how many places that can work. Then you have to chart out where is best. Maybe by chance that person fails in one calling, it doesn't mean that person fails in another calling. Sometimes a new guy doesn't claim I can do this and okay, where you will send me, I'll do. That person simply says because the person will do. But once that person gets into experience and you observe that, you can reuse that person somewhere else. You know what that person is. So it is you to decide which person should be where and which is a job of management. You know that person, how that person works, without giving, extracting the feedback by the person. Once you know that this person can do this, this means this person can be used. And that is what management is all about. If you are best in extracting best work, best output from human resources, your machines shall give you best output. Your methods shall give you best output, and you will get optimum use of resources or best use of resources. This is what is required. Means best use in time. Means avoiding wastage of time, avoiding wastage of rework. All that counts to standards, counts to quality in that case. Because say safety guy is there, if that guy doesn't control site and some stone is lying here, some is lying there, accidents will happen. So you have to explain to safety personnel, so what is your job? It's not necessarily what safety people learned in that institution of safety, knows everything, certification one part, but site has got its own problems. You cannot keep every material all time in some standard stacking position. Sometimes it appears that site is very untidy, and sometimes seems it's very tidy, but both are actionable, both are required. Both are required. But attempt is required to keep as much as in tidy position as much as possible. This is all point of management. That is what I'm saying, and we learn from that. So I will now again come to point about this ISO 9001, which I talked of before going further. I thought to explain more, but let us stick at some point for a change as well. ISO 9001, which is original document, and this has I explained before many times, and I'm just trying to refresh this clauses which are in tabulated form, and in one column it is clause number, in another column it is, you can say, title of that clause, and in third column it is, that is called description and intended actions related to PDCA. PDCA, P stands for plan, D stands for do, and C stands for check, and act stands for A. PDCA. Plan, do, check, and act. These are four minimum sequences for something you decide to do. Plan it, do it, check it, and you find something they are unacceptable, act on that. So this is general. So clause 1 is there, which talks about scope, and the scope, you know what is intended outcome of management system, which is industry specific and should be aligned. Now to class 4. So class 2 is normative references. Just like class 1 is a scope, class 2 is normative references. Means references should be there. All references, designed references or pre-work references to all references that will be used in work directly or indirectly. And that is clause 3, which is terms and definitions. Whatever term is specifically is used in a standard form, that must be detailed out for reference only. Then clause 4, which is context of organization, and which is very significant because it gives us organizational understanding and expectation what parties do have, and of course management system that we have determined to use, and that system. This is that type of context which is very big one, and every organization have different definitions, explanations of this. Then this clause 5, which comes to leadership. Leadership means industrial leadership, work leadership, project leadership, and that type of leadership which comes into play on these projects, which are our construction engineering projects, and that is what we do. So this is leadership in clause number 5, and if you go down to clause 6, which is planning. As I said, planning plays very important role, and planning means what are risks we have to understand, we have to address those risks. Of course, when risks do occur, this brings some challenges also, and challenges when understood well bring with it opportunities. And we know what are our objectives and what we want to achieve. That is what planning would help us. Then support, that is clause 7, and support means physical supports and informative supports. So this is resources, is competence. Resources means equipment resource, or you can say workers resource, or staffing resource, or external resource, and then competence of persons who are responsible, key person, and then awareness about everything, and communication resource, and document information. All these come into support of ourselves, support of projects. And then you see Clause 8, which is operational clause. Operation clause means we have to operate, we have to plan, and we have to control, and there will be internal as well external both, and overall, when overall management, process management, and then manage plan and the intended changes. And 9 is performance evaluation. That is very important. Means you have to monitor, you have to measure, you have to analyze, you have to evaluate, and you have to do audit, internal audit as well as external audit, and then management review as well. And after that is clause 10, and that's improvement. You have conformities, you have non-conformities both. You have to think where you failed or where some observation came out and used. Observation should tell us what's the basis, what's the reason that you should, where's fault line, that's what you do, and then continue improving, keep on changing and changing and changing, and you will get some perfection somewhere, and you will get some mark somewhere. And after that, if you go to is what are this ISO, and we know that there are two criteria for this, and there's various parameters required for this, various information required for this, medium required for the paper medium, magnetic medium, or electronic medium, or photographs, or videos, or samples. All this we need to justify that we are doing work on management. We are doing work according to this international standards, directions, and then that includes about you can say documented information that is in part of a high structure level. This is we are talking of, and then other documents, and communication of information, and then there's evidence of conformity, and then there's knowledge sharing, and then dissemination. All that is must. And then you can say document requirement. What sort of document we require? We require mandatory document or not mandatory document. Document mandate means which are given as annexal. That's very important. And those documents which are not very really mandatory, depends upon organization and to organizations what activity of organization does and what programmatic results. Based on that, you can draw documents, and that's where it says that there are two sections of documentation. So we are talking there, and then you can say what is, as I say, the scope of quality is considered the scope quality management, document information necessary, and quality policy. But we are talking quality objectives that we take care of, and this document information is then there exists. And what is mandated, and others which we have options of, like options of organization chart, how we devise that, and process maps, which is our design, and process flow charts, all design issues or process descriptions. That all is termed as engineering in combination. Then there's the technical and administrative procedures we have to decide ourselves, and work or the test instructions we have to decide ourselves. Then specifications of project, general and particular, and all our decisions and I mean to say employers' decision with our support. The documents containing internal communications, and then schedules, as well as approved suppliers list, and all testing and inspection plans, and quality plans, and quality manuals, and static plans and forms. All this with many more. So we can say that this is document needed everything to be retained by, if it is if it is terminated one with other person, then that person must have all these feedbacks automatically, and that is important. So we what I say is these are records which I already told you. I'm not going to repeat that again. You have in previous talk. I'll just now go to another one, and which is now uh, which is now designs buildings technology template. That is a new template. I have talked to you about construction of buildings, and I have talked about supervision of buildings, and this is in addition to original one, that's guide. I just explained to you points, though that's a format actually. You have to use that for, and we use this for building constructions, and we use this for supervising of those buildings, supervision of those buildings. And now it's about uh, designs, RCC designs buildings, and this is very significant from that viewpoint. And let me read just for you that This is a quality system of RCC designs of buildings, and it's an organization which adopts a management system to take care of comfortably achieving its best objectives, which being in this case the RCC designs of buildings. Management system, we know all, comprises various sets of procedures for charting out and implementing various operations or activities so as to successfully reach its intended objectives, which which leads to enhanced use of resources, improved improvement on risk management, and increased customer satisfaction by meeting product or services expectations. In this case, product is RCC designs. So building, let me repeat this because it's very specific on deployed. First one, repeating the deployed, I cannot see it correctly. Yeah. So I say management system comprises various sets of procedures for charting out and implementing various operations or activities so as to successfully reach its intended objectives, which may lead to enhanced use of resources, improvement, improvement on risk management, and increased customer satisfaction by meeting product or service expectations. In this case, we have to do work with RCC designs of buildings. Now, organizations do work on various management systems, say quality management, environment management, and safety management, as we said all before, and all these systems apply in this case. And these various systems in line to management of ISO 9001, and previously it was 2008, IS 9008, and these used to work independently in past times on varying management structures, causing inconvenience to interface with each other. But now all these issues shall be dealt with as framed in a common template, and that is NXSL, being a high-level management system, has produced a common platform so as all systems that organization adopts can be drawn based on NXSL designs or format. RC designs of buildings can be easily defined within that format. Now, such arrangement provides many commonalities in this design system. Means this is design system and implementation of that, monitoring and evaluation of that, and improvement of that by trying to eliminate conflicts that existed before in 2008 system. Varying stages related designs of RC buildings can be covered within templates successfully. So all management systems shall have single high-level identical core text with common terms and definitions which can be defined within Annex SL. Yes. We are going back to same system again. High level structure cannot be changed, but discipline specific subclasses can be both added or changed. As such, additions may be made where required related to RC buildings designs. Then Annex SL applies to all management system standards, publicly available specifications and technical specifications, as well as customized requirements. Revised system meant to say this ISO 9001, 14001, and 45001 shall all be based on Annex SL high level structure where related to, in this case, though not included herein. All right. Then Annex SL template, which is now we are going to discuss, is only for indicative guidance to apprise engineer how new system adopted by This organization ISO 2015, 2001, 2001 to 2015. This ISO effective September 2015 worked to produce organizational prime quality document which shall govern whole organizational quality process required by business adding business adding accountability shareable by business or technical leaders. Wherever and whatever requirements, demands, items can be added as subclause, but no no deletions, you have no right to delete what is included therein. Don't delete anything if cannot be added. You can add something to sub members, not the original one. Purpose of this template is just to project quality track demanded by ISO 9001 system, which is a mandate published by ISO and without which applications all existing regarded to 9001 ISO 9001 2008 registered certification shall stand invalid after 3 years of September, since September, so it's already 3 years. Therefore, this Annex SL adoption is a must for new quality system globally. So we are going to read now this system. Let me stand for half an hour to stretch my legs and talk to you by standing. It's already no problem for that. I think it's not any problem. Let me stand for a few minutes. It's just because I'm feeling lazy. No problem. I'll stand. Now, as usual, I told you about format of ISO 9000. It is clause 1, which says scope. So it says that includes outcome of management system which are industry oriented, still specific, and should be aligned with clause 4 context of organization. In this say scope, what is the scope? And this you have to include here. To be included, annex SL template is the delivery of designs. Our scope description is delivery of designs of RC buildings. We are talking of that. Then we are talking feasibility survey report to delivery of working drawings. This is a range, and we are consider physical survey on what we are going to do for this project, and up to a point when delivery of working drawings is made related to residential, commercial, institutional, or hotels or whatever. This is a we decide this scope ourselves because we are doing marketing, we are doing engineering business. So we say that delivery of designs of buildings and from survey to delivery of drawings is our scope in relation to residential, commercial, institutional, or hotels or others buildings. That's what we say. Then we go to clause 2, that is normative reference. Now what we include in this? We include references. We can say details of references sessions on publications relevant to particular standard. Which standards could be, let's say, Euro codes could be, ACI could be, IS codes could be, BS could be, and various national annexes and NDFs and PDs. You may know be knowing about annexes, this is NDFs and PD if you have gone through European courts superficially or through their contacts. You must be knowing about this. We have all codes with us. As we should have all this information with us, and because we are working on designs, we must have information from this. And if some information missing from this course, then our nation must fill that in, these blanks or this information not able. We have our nationally national parameters that, or we have published documents, whatever, which are suitable for our nation that we must have, because every country has certain options in that code of European code that we are saying this international standard and some information which are not international. There's a specific one, which is economy specific, country specific, you have to fill that on your own, those points, and that is your publication based on this publication, a standard publication. So this could be the European document 1990-2002 basis of designs. You can say a standard one, because we are dealing with basis of designs, we are dealing with design. So that can be one reference, 1990, that's European code in which on 2002 basis of designs, and then there's actions means 1991, and there's 2001 2000. There's actions, and then there's actions by fire, which is 1991 1 to 2002, and different like that. If you go on speaking, I cannot give numbers in everyone. You can go yourself, see. I can say actions. First is basis of designs, and then actions by fire, and action by snow, and action by wind, action by thermal energy, and action by execution, action by accidents, and design concrete. You can say design concrete, structural fire, etc. And you may say then other codes like ACI, BS, sorry, BS, NAEN, because the 1990-2005, and ACI 318, American Code, Concrete Institute, American Concrete Institute, then IS code, our code is Indian Standard Code 456, that's 2000, which is under revision now, and NBC, that's National Building Code 2005, which is a guide document for all states here, and building bylaws related to area of site location. These are few. Then we can say clause 3, terms and definitions. Terms and definitions, which says means detailed terms and definitions applicable to particular specific standard, in addition to forecast. You can say that's the foremost related terms. Let's say in terms of what type of building we have design, building type, structure type, FAR, or what can say covered area ratio, it's called FAR, floor area ratio. Then you can say each floor covered area. Then limit state requirement, which one we are going to use. It is serviceability, limit state, or it is ultimate, or SLS or ULS in short, these considerations. Then seismic zone limits, which seismic zone it is in our country, zone 2, zone 3, zone 4, like that, zone 5. The cast in situ concrete, or it's precast, pre-stressed concrete, or it's a combination of two, and then concrete class, reinforcement grade. These are all references. Fire control, reduced section. Reduced section is very important. This is where the fire control and reduced sections are related to each other. The non-linear analysis and linear analysis, software use, which we are going to use, then basis of designs, and design estimated quantities, and global structural element, and schematic designs, not working designs, I mean to say, the issue for information drawings, and issued for building permit drawings, and issued for construction drawings, road revised designs, and all other necessary definitions. These are very important definitions, terms and definitions, because building type, This is simply saying what type of building this is. Yes, you can say residential it is, commercial it is, institutional it is, or someone else. Can be for any use, whatever use. That information must be known because you have to design some of the criteria based on that criteria. It can be a bungalow, it can be residential flats, housing, it can be some garden, or not, I mean, garden guard house, you can say. It can be institutional building, school, university, it can be some other building of for a conference, it can be a club, it can be hotel, it can be resort. Means there are many structures are built. Then what sort of structure you know that? It can be very complicated structure, or light structure, it can be very still structure, or concrete structure, some other structure. That structure type you have to classify before jumping on to drawings or the designs. Then what is floor area ratio? You can say floor area ratio is called covered area. You know all that. 1% of total plot area should be covered area. Then, because this relates to bylaws, if you do not understand this, of course you will be given this drawing by some architect, even then you must know that. Because there are so many complications in those floor area calculations. And then each floor covered area, that's also very important, just to, because this affects design at varying heights. It's not uniformly covered. Then limit state requirements according to new EQs, which are European Union codes, which are 58 in number total. In new definitions, serviceability or ultimate loading, ultimate loadings, then means which you have to consider best for you, means you are going to use serviceability standard, serviceable loading, or ultimate loading, because in ultimate loading you consider the condition of the collapse, while in serviceability you are not going to consider the collapse but only up to a safe value where you can safely stay in that building and you can feel comfort with its elevations, all that. Means you are free that it won't collapse, I was saying. But the other one, you have to reach little lesser than state of collapse, so you're safe. Where material final properties are considered, you have to reach to material's final property even in plastic stage of that material. So this is what I suppose, and go to seismic zone relevance. Means your area may be zone 5 to zone 2, very dangerous to zone 5. Well, no. So you have to see what sort of zoning it is according to our code, national code. Then cast in situ concrete, that is very dominating and general, cast in situ for all normal projects, and is very high magnitude, vast quantity element that is used, and it actually, truly speaking, this this term cast in situ concrete requires attention for quality, for material, for quality, for workmanship. Every every property it must have, because it is done on site, it is done by direct workers, it's done by machines, and various hands change work on this. And with thousands of hand work, you can say perfection is not expected 100% because of human involvement. But if you see, you can say pre-stressed concrete is used, that is a little different. There is control in factory, and it's not that risky because work is in factory. Safety is only for operation of machines, and work is done safely and with quality, good curing, and complete designs, satisfactory designs worth it. We go to concrete class. Concrete class means grading, ingredients, and results. Means how this conducts, how long can it go, and how can it best fit in to this structure. Then reinforcement grade, because concrete is there, reinforcement must be there. What grade of reinforcement we are going to use? Then fire controls. Fire, which sometimes people ignore in designs, but remember, fire is very important factor. If that is ignored, you will invite immense dangers. Wind forces can be controlled on building, you can say we can manage. Seismic forces can also be to some extent resolved, but fire does not listen to anybody. Fire got no eyes, no mouth. Fire got nothing. It, it is different, it cannot be measured, it cannot be stored. Its effects can be understood. The fire is actual fire. It fires you, it fires building, it fires material, it fires the structure, it fires everything, every point, everything. And it reduces use of concrete to much lower extent than it was, and that is where reduced sections come into play, which is very important to understand. Reduced sections, fire is not the, my size of concrete column is 40 by 40, say 400 by 400, and when there is fire, it applies from all sides. So surface as that column is impacted upon by thermal energy, and this surface starts getting heated up, which means reducing its strength power, reducing its compressive power, its tensile power. It's really don't consider compressive power because of the fact in concrete. It reduces its power from around its surface. This means if you go inside that concrete, still there is safe material, safe section, while external section is reduced due to high temperature. Certain portion inside is still safe, and that certain portion maybe 50%, maybe 60%, maybe 70% until fire is suppressed. That portion is called reduced section. Is that section is safe for its, whatever section is there, you can value that one into your calculations for its re-strengthening, or how much or to what extent this building can work. Because if it collapses, that is different. That is called reduced section, and its details are available in European codes. Which we can, it's in, it's not exactly in same shape inside as your member shape. It is, at some temperature is high, maturity. If you enter inside say 1 centimeter, that temperature is little less high, lesser than external temperature. If you move further, say let us 2-3 millimeters, it will be further reduced. So ultimately there is zero somewhere, or reduced to some days like 50 degrees Celsius, and you reach there, it's their friend. So you try to understand what I'm saying. Section square coverage is reduced, and that point we have to understand. So you have to repair that or retrofit that. It involves that an internal portion can be used while you're retrofitting by external periphery. So encasing or by whatever means you do it, or you can say what you call it, jacketing or encasing, whatever way, or strengthening by chemicals, retrofitting by chemicals, that this part requires to be understood well, and that part is reduced sections. Then non-linear analysis. Non-linear. We generally do as common engineer linear analysis, stress upon strain. equal to young modulus and it's proportional. And this is curve for steel reinforcement, this is curve for temp concrete. All we understand that. But when you go further on that, we are going to be yield, we'll go to some other world. This is stress and stress proportionate is terminated, and that is yield strength. And then for the plastic strength, plastic strays, that portion is, you can say, non-linear analysis. So curve one, this is not linear. You're not sure about conduct of a behavior of a material of concrete and steel there, and that is non-linear. All designers know that. This is actually their design in their own substitutes. So this is non-linear analysis. And then there's a linear analysis, I said, is a range where we consider stress and strain and we form our elastic modulus, elastic coefficients. Then software used depends upon you. Means you are designer, you use StatPro or use some other software, e-tips of a call, or you don't use software, you use your mind and basically work there using Excel sheet or some other. That's your choice. And I cannot say on that, and because I'm not very experienced on that stat or something, it's not my field. So though I understand that, then basis of designs, that is exclusively design part, where we start with what shall be our basis of design splitting. We cannot simply say I design this column or that column or this beam or that. That is not called professional design. That's called learning, means how to learn design. That's completely different. Means we are not talking in profession about that how to design a column or a beam. That is last. First we have to understand design. As I said, I talked an example, that is tool example. That way we have to understand how the structure is going to conduct during its use and further use and further use and during whole life cycle. That point we have to take into our consideration or criteria of parameters, that what we expect this proposed structure to behave, and that way we have to think how it should be united. Those elements which are going to be, how they should be, how they should constitute a framework in 3D which behave accordingly. That basis we have to design. We have to form that philosophy for that. If not in writing, in our minds, also possible. If you cannot give it writing, not necessary. But your system should be there, whether in software or in mind, that is what I constitutes a reference. I'm going to decide how it should perform and what load it should have. Should this be considered essential building or ordinary building? What sort of materials I'm going to use, and what is soil investigation report speaking, if there is? And if not, there is no, is it essential to conduct soil investigation? All that must be considered primarily in basis of designs. Then design estimated quantities in the operational way means just constitute budget. I know we cannot give quantities accurately, but based on experience we can say this building may require so much quantity of RCC or structural steel. Not because we know that, because we experience that. It's not thumb rule, assessment only, which would vary 10 to 15% in final results. So estimation they have to take this way. Then design estimated quantities we have to see. Then global structural elements and schematic designs. What sort of structures we can do or we can find from the sources? What type of structures and sort of members they should have? Or elevations require something else, architect requires something else. It's all point of considering in structure. Schematic designs just give something that we want to do this way. And after that, if we have schematic designs ready, we can issue certain informative drawings, not working drawings. to our client that this is what we are going to do in elementary way, not in final way. Or we can then produce, if accepted, that building permit drawings, which means that space use this is going to do. We are going to cover this much area with space, and that's called architectural drawings as well. Building drawings issued for building, but generally structures drawings also must be issued, but because of so many reasons in our country they are not using that. They are just depending on certifications by structural engineers, which is not right anyway. Then we can say issued for construction drawings. After that, everything is done, everything is approved, then we have to start construction, and for which you have soil investigation done, everything is done, couple information there, material information is available, and your design is ready. You can draw, you can design, you can detail out, you can consider all ductility, non-ductility, this requirement, that requirement, and that is design drawings. Many drawings for one building and hundreds of drawings for many buildings, and that is used for bidding, that is used for tender, that is used for construction. And then if there's a change during work, there's some requirement, then you have to, not necessarily you can say 100%, few percent, some additions maybe there, something maybe the omissions maybe there, then you have to consider revision of design if it is required due to some reason or which is not going to affect your project. And then all other necessary definitions whatsoever they are, these are our references. You may call them references or you may call them terms and definitions. These are very limited I have given to you. And then we go to clause 4. Clause 4, which is context of organization. That is actually, again, it's a repetition of our management system that we are going to talk about. This system is, of course, very important management system. Context of organization, as we all know, it says, I think only a few minutes left from program. What it requires, we have to do for it is understanding organization and its context. That's all. As usual, understanding needs and expectations of parties, and determining scope of management system. Then what points you have to consider are why organization exists actually, why we are there, big question mark. Then identical internal and external issue that impact intended outcome. Then interested parties and their requirements, define the scope and set boundaries of management system, and raise employees awareness and involvement. That's what we are going to talk in this text, context of organization. And we can start like this: organization intends to serve public. Of course, we have to serve public with best possible design deliveries related to such buildings of RCC, and and intend to help public avail benefits of best technical know-how regarding RCC buildings, either directly to owner of building or to professional architect appointed by building owner, as case would be. Organization is a small group, of course, because we are consultants or technical experts with high level profile backup of design engineering or engineering designs. Attainment means competency, what we learned. And organization undertakes that its professional and social responsibility to contemplate, analyze, consider, and reconsider to produce best and fittest design at economical and sustainable ecological cost. Organization understands that its product end user expects best sustainable economically, ecologically, and within budgetary cost graded with quality. Control product, all such designs that can assist site work with minimum efforts and maximum benefits. This is what quality it should have. Again, this paragraph. Organization understands that its product and user expects best sustainable economically, ecologically, and within budgetary cost graded with quality control product, all such designs that can assist site work with minimum efforts and maximum benefits. And organizational leaders ensures that it will understand requirements mandated by laws, regulations, honor, architect, engineers, and others. I am saying architect and engineers and others. So everybody is involved in that. Internal issues are references to mandatory and advisory practice, national and international codes, updated design resources, drafting resources, which certainly are given due care. External issues are coordination with statutory and government authorities, appointed architects and owners representatives, as well as direct and indirect impact groups which need to be taken care of. Organization leader makes sure that there should be no delay on implementation of design delivery schedule, which if delayed shall mar site prosecution and impose on consequential delays on project completion. This management scope determined to be limited from, let's say, feasibility study, architectural designs study, contemplation of structural design, development of structural design, services coordination, inclusion of regulatory provisions, productions of detailed foundation and floor layouts, working out structural detailing, all drawings coordination, resolution related to disciplinary clashes with other professionals, coordinations with other professional vendors, for example, elevators and escalators, vendor, etc. only, production of project structural specifications, production of all drawings and proof checking, and testing procedures and total delivery of all design products in stages to all related parties. To accomplish foregoing management activities scope, ISO 9015 very well permits to be applied with and operated for all such works. All such operations to be susceptible to ensuring compliance with management system, and all such operations be placed in for further improvement in all cases, and such product be used as future resources. All our involved personnel shall be put in system training from time to time and would be required to update adopted system and also requested to submit their experience based suggestions for improvement. All personnel shall be advised to understand whole system so as not to miss whatever activity on design projects. These are basics. Means these are not very specific. That these are normal. And then clause 5, which says leadership. Leadership exists everywhere. That is where we have to think about. And let me sit down. Only leadership I am talking is that is leadership and commitments, policy and organizational roles and responsibilities, authorities, etc. Then which points we should consider? And that is emphasis on leadership, not just top management, but leadership is responsible and accountable. Top management has greater accountability, involvement in organizing management system. Means top management has greater accountability and involvement. Then integrate requirement of management system into organization core business process. Then ensure that management system allocates necessary resources and achieves business intended outcome. The top management responsible to communicate importance of management system and ensures employees awareness and involvement is general. So we can now start saying that all partners are heads and leaders. All partners are heads and leaders to their respective sections, such as design, development, detailed design and drawing specifications. Policy devised by management and leaders is that work should be done first time, every time, no repetition, which is the best one, first time, every time do it. This means you have to think a lot while doing work. Don't just take flexibility and then you are ready to do work. Again, no, that's not required. This is basic principles. Work should be allotted to all right persons only, and if right person is not available for certain specific job, either training should be given to personnel involved or work should be outsourced. And work should be affected in scheduled time with required degree of compliance. Attempt has to be made to do work error-free to a maximum extent possible and feasible. An organization has devised various levels of positions such as top management, middle level, senior, and detailed managing levels. The top management contributors are leaders in themselves to direct and guide all others, who require to provide vision to organization and who require to keep all personnel all times motivated so that continuity of personnel is maintained, which is very important because these are resources, competent resources. Then leaders need to ensure the policy of organization is effective and objectives are achieved in all cases, and they need not involve directly with details but involved with surveillance of all works of designs. They need to make sure that required resources are available all times as and when necessary. They need to ensure that all personnel at all levels know respective job activities which must be produced in descriptive writing and be updated from time to time depending on newer projects. They should keep efforts on for organization For organization, bring more jobs for organizational future, part of business, part of progression. They should provide required job training to all personnel depending upon status and competency of persons. And then leaders have to in all cases, all time ensure that device management system is well monitored, evaluated, and necessary improvement is inducted into this. They need to ensure that all necessary information regarding system management is communicated to all personnel as and when necessary. This communication is. Leaders need to ensure that all clients or respective owners are well aware that organization has been complying with newer requirements and duly updated so that it be easier to participate in newer designs, bid to manage designs. This is about leadership. There are so many other points, but these are important points. And then we come to planning, that's clause 6, which again says that action to address risks and opportunities, management system objectives, and planning to achieve these objectives. And what we have to consider, bring risk-based thinking to front. Once organization pinpoints risks and opportunities, it has to work out how to resolve or address through planning, and what, who, how, and when these risks be addressed. This approach replaces preventive action and reduces risks for corrective actions later. Objectives of management system should be measurable, communicated, aligned to management system policy, and updated as and when required. And then let's say if we define that further, can say what points can be considered research structural designs contracting, not easy to decide, but let us say feed is not available in time, it will cause risk. Feed, which means front end engineering design, means what actually you have to decide basis of that can be drawn from feed in a professional way, and say that that's not available, so this can cause an impact. And if the information required from client is not available in time, so we work stops, means actually information must come immediately, but sometimes it happens because information from client is not easy to get in, and which can cause waste of potential work hours. Then site surveys are not conducted in time, you cannot get information about site, so you can move further. Then site soil exploration is not carried out in time. Personal soil investigation has caused a big problem. Maybe there's no laboratory, or there's no computer, or there's a laboratory is busy somewhere else. You have to make sure when that no time should be wasted on that. And actually working information must come from field in time, and detail can come later on. An architect delays issues and required drawings. Architect delays some drawings which are most used on your designs. Then services engineers delay issues related to allied drawings, allied services drawings. After that, we'll say that national parameters are not available. National parameters means not our parameters. Parameters that were required, that are required to fill in EU, that's European codes, are not available if we are using European codes. Required to be worked out. And design service of contract payment are not released in scheduled time from client, means delay on a consultant's payment itself. Your payment that you are getting in time due to whatever reason, this can also hinder and provoke. Then right services of kind of payment are not getting this, and then all foregoing, all these, as I explained, issues can be checked by intensive engineering coordination from very start of award of service contract or inception of award of service contract. Then we can say every leader responsible for task should follow should follow progress by all interactive persons, all times, and status updated. And issues should be raised in internal as well as in external drawings, external meetings, you know, particular meetings of a drawing at this time, drawing other documents. But let us say it should be raised, we can raise this issue about delays on execution, which is ultimately delay everything which we are doing. Then we say all minutes of meetings should be recorded and communicated to involved personnel formally, later on giving reminders and further follow-up of related activity updates. I'll take class 7, 8 and 9 later on because of time constraint. So I'll now just concluding, so what we are talking of. So far in this management system ISO 9001, which is very significant for engineers, not just to read what they are saying, but to just understand what we are thinking. Is we have gone through from basics of ISO norms and acts, which says about these 10 clauses in every format, but we have to understand what our activity we consider ourselves, and we consider all those basics, and we try to understand what is your construction of buildings, generally RCC. This can apply to others also. What way we should understand that in a way that we are benefited, in a way public is benefited, and professionals can get better use of people. And I cannot say that there's a direct method for us, but just the guideline it is, and we can apply those points in minds. And because maybe we forgot that during our educations, but later on we should understand something, and that's not failure actually. When we say that we are having same for construction, and which includes material itself and equipment and as well as human resources, which all cost. So in fact we are not only controlling our use of material and resources and equipments, but also same time we control budget there. Budget, which is very important, is escalated due to delayed work or delay something. Budget cannot be controlled, and because we don't get fund immediately, and if you get fund immediately, then there should be no such problem. But after that, you see what happens. Monday comes and there can be some other problem in our that. Means we cannot start week, so we have to think that way. We should not waste time. Our Monday or some way Saturday comes. We should be ready every time. We should write the plans, date to the plans, and we have no right to waste time, because if you waste time as a company or as a owner, then we waste our time, we waste others' times as well. So this point must be carefully considered in our execution methodology. Execution methodology and method statements are different. Why I'm talking execution methodology? Because project itself is execution work. Execution work in a way you take over from someone and deliver back to someone. You take over an open land or a plot of a land, and after doing everything, after doing all compliances on contract, and you deliver it to site where it's going to be installed, where it will be operated on, and that is where we use our services, our designs, all that. What service we can give you? Of course, design is not our prerogative, but yet that has to do something for us. So construction involves all other sectors. You do not just take it for granted that it's construction will do it. It involves a lot of input from every source. That is what we have understood. That's what we talked of. Important factor is machines, which are very expensive. And these machines can be operated only when human resources, competent human resources. So competent human resources percentage wise is not that expensive as machines hours are. There's a lot of difference. Machine hour can replace thousands of man hours workforce. So we have to require that level of competent people who move fast with machines, operator, workers, technicians, artisans, and supervisors must have brilliant minds to immediately keep these machines working. If these machines do not work, if these do not perform, We cannot say that we are using it idly. When they break down to something else, but they work it out working order. And if you are paying from your budget, then it will impact on budget if you're not using them optimally. Questions will be on us by our controllers. So this is what I'm saying, that we have to think this way. We cannot simply say we are in construction. In construction also there are many elements. Many elements means so many elements are there, so many elements are that it's very difficult to tie up with them. Somewhere we lose something, of course, somewhere we gain something. Both chances are there. Losing chances dominate. Lose time, you lose use of material, you lose everything, and that causes a problem. And that's what I'm talking of. Who's this person? Let me see. Darya. Hello, please, are you there? I'm not getting your video. Hello, hello, gentlemen. Are you there? Good morning. You want to say something? Only this? Okay, wish you all best. Thank you. Wish you all best. Okay. I don't know, just people want to do like this, don't want to ask. I told them raise questions. If you want to get use of this medium, you can raise questions about construction, about engineering, about our national issues, constitution. I know little, I can answer. But no, only this. I want to see your face. My face, I don't know what's on my face. I don't know what talk people up there. Well, I was just continuing about means we need skilled people. That is purpose of my talk. Skill is absent. We need skilled masons, skilled shutting carpenters, skilled fixers, skilled operators, skilled vibrator operators, skilled engineers, skilled workers, and all those who can upgrade these skills, who can teach on site, who can teach in institutions, who can go to other sites and explain to them how to do, how not to do. And we can call university students, college, come on, learn here for a day, for 2 days. Can we do that? We are not doing that. It's picnic they are going to celebrate on site. It's not picnic center. Yes, we can entertain you, but you have to learn. That is important. If you learn something, it is useful for you, it is useful for us, it is useful for nation. That should be purpose. It cannot, we know it can't be developed in one day. It still can't be developed because those who are educated, one, they too are not developed. If an engineer cannot write a good drafting, I don't consider as a communicator. If an engineer who is hesitant to write and communicate just what I have, my question is, or even technical clarification you cannot write for, forget administrative letter, forget contractual letter, technical questions you require to raise to designer or to some other. If you cannot do that, only technically you cannot communicate. Communication is a part of job, it's part of engineering, and why should we miss that? That's the point. Means if you cannot communicate, you cannot understand from specification, that's same thing also. You cannot communicate from contract, you cannot communicate to your mind, you cannot establish link between mind and the specification, between mind and drawings, between mind and some document of contract, some other information. So that is a question, that is a point to raise eyebrows. This skill development for engineer is required, for supervisor is required, because you are going to communicate with those who do not know ABCD of your profession. They are laymen for you. They may be administrators, they may be honors, they may be general public. Communication in every way is important. You are going to have some dispute in future. You have to communicate to your counsel. How shall you communicate? You shall communicate to your arbitrator panel. How shall we do that? That is where communication lies, and it's really very important that we have to understand that in our execution way. Execution way, that I mean to say complete project execution. How do you want to start and how do you want to end, and what stages shall you cover, any standards of a company, or you want to introduce something new that we have to write, that we have to understand as a, that's actually kind of working policy, project implementation policy, you can say. It's not simply execution statement, it's your mental statement, what you plan in your mind to do this job for, how you want to plan that. It's direct your mind, just you have to go to site every day and tell, or you give some writing to some important person of client, owner or supervisor, or to your own manager, so that that acts as a guideline that we agreed with that, because this plan, this execution plan or execution statement shall make a contract document because you submitted it during your bid. So this becomes an instrument at one stage, so that must be taken care of. You have to be clear in what you are going to do according to the data. Yes, it can be revised in date, it can be track can be changed, but still it applies. Responsibility yours, no one else. That is what is a more serious concern, that we have to stay to that, and that is purpose of execution, that is purpose of construction. And then we talk of supervision also, where consultant or engineer has to supervise work of contractor, which is a disputing relation sometimes, and which is a cordial relation other times. Because contractor has to do something wrong, it's natural. It's not intentional but natural, because everybody is not perfect. Contractor employs not that kind of high profile people, but those who accept lower salaries, or who can say, okay, on site it is possible. Such type of people can work because he is not independent as person. So that kind of approach procures to site substandard people or lower quality people, and you can say that causes a problem. Pain, and someone's coming. Yes, yes, hello, 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 someone there? Hello, good morning. Anything to say? Hello, hello. Good morning, good morning. Yes, you want to say something? I am live. You want to say something? People will listen to you. Do you want the question? Do you have any question? My God, what to do with these people? Unnecessary, no. People are like that. See again. I'm going to conclude. Yes, Mr. Please. Yes, come on. Tell me what you want. Hello. 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 What do you want? What do you want? Hello. Useless people. My God. This country. These people are just coming to this or showing chest. What to do with chest? This stuff for nothing. Well, supervision always acts like a police, though it should not, and contractor acts like somebody like a thief, though should not. But practically it happens. This should not happen. You are paid to do job, employer is paying expert job, and I am there to ensure you are getting paid, you are returning that law. This is a relation, simple relation. One person is paying, one person is getting, one person ensuring that quality is there. Both are there, three parties are there on two contracts. So we cannot understand this point. Why we think that contract is just a robber? Do your job, you are paid. Why you think I am your police? I am not your police. I am there to help you. I am there to help you means I am going to help this project for that employer who is spending money, but not for the employee. In fact, I am going to help it for its future use. That is my intention, nothing else. If you cannot understand this point, I can't help you. You are my friend, you are contractor. I'm your friend, I am employer. This is my friend, this is engineer, and you both are friends. work friendly in interest of project so that it benefits future and next generation and current generation and economy. That should be an objective, nothing else. But we do not consider that because our mind setup is different. Goal is same, project delivery same for these three people and for public. But no, because we are born like that, we cannot change our culture. All our professions, employer is a professional of economy, finances. That is a professional of construction, expert in construction, and this is a professional supervising expert or design expert. All three are expert and they should behave accordingly. That's all I want to say with this. I close this. Thank you very much. Bharat, you are all, thank you all was present here.